As I said in the previous class that we will solve previous year questions of sets and logarithm in this class. Okay, so let's start with this first question. This came in JMA in the recent year only. So it's saying that an organization awarded 48 medals in event A. Okay, so an organization awarded 48 medals in event A, 25 in event B, and 18 in event C. So it's a question of three set Venn diagram in which three events are there and 48 were distributed in event A, 25 in event B, 18 in event C. These medals went to total 60 men. So our universe is of how many elements? 60. Okay. Total number of people were 60. Okay. And only 5 men got medals in all the event. So basically they are saying that A intersection B intersection C is what? 5. So we have to find how many received medals in exactly 2 of the 3 event. Exactly 2. We have done the formula for this exactly 2 also, if you remember. Okay. So let's write all the data here. So it's given that n of A, number of element in A is given as 48, number of element in B is given as 25, I think so, yeah, and number of element in C is given as 18, and total number of people, total number of men was 60. So A union B union C is equal to 60 because all these medals were distributed among 60 men only. Okay, and last thing they have given us only 5 of them got all the 3 medals. So A intersection B intersection C is 5. Okay, so obviously we can apply a formula here. Which formula here? We can apply n of A union B union C. N of A union B union C formula, if you remember, n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. This was the full formula here. Now we have some values here. Which values we are knowing? We are knowing values of A union B union C, which is 60. This is 48. This is 25 and this is 18. We don't know value of these things. So I will take minus common. A intersection B plus B intersection C plus C intersection A. Correct? A intersection B plus B intersection C plus C intersection A. Correct. Plus this is 5 given. So I will bring this in here. So it will be n of A intersection B plus n of B intersection C plus n of C intersection A will be equal to how much? 48 plus 18 is 66. 66 plus 25 is 86. 91. 91 plus 5 is 96. 96 minus 60 is what? 96 minus 60 is what? 36. So we will get our answer as 36. Now please read the question again. They are saying us exactly 2 of 3. We have to find exactly 2. And what was formula for exactly 2? The formula for exactly 2 was, I will draw a Venn diagram here, then you can remember the formula. For exactly 2, we draw A, we draw B, and we draw C. A event, B event, C event. This shaded part is known as exactly 2. So what we have to do? We have to add A intersection B plus B intersection C plus C intersection A minus 3 times A intersection B intersection C minus 3 times A intersection B intersection C. So exactly 2 formula was n of A intersection B plus B intersection C plus C intersection A minus 3 times A intersection B intersection C, correct? And we have already got the value of this thing, that was 36 minus 3 times it is 5. So our answer will be equal to 21. Option number B. Everybody understood this thing? Any doubt in this? Being side here. Yeah, Dhanush, you are not adding 5. 5 is also written here. If you can see, this is 91. Yes, correct. And this is equal, this is also there, no? Plus 5. So this will become 96. Okay. Can you move on to next one? Any doubt in this? Or can we move on to next one? Everybody understood this thing? Okay, nice. So let's move on to next one. Okay. Try this one. Yes, please ask it out if anyone is having. Other, please write the question. Take a minute. Take a screenshot of this fast. Yes, tomorrow is class there. Okay, let's start this question. Huh? Out of all patients in a hospital, 89 are found to be suffering from some heart ailment. Okay, some 89% are found to be having heart disease. 98% are suffering from lung disease. 98% are suffering from lung disease. Okay, so we have been asked K percent are suffering from both of them, heart disease and lung disease. Correct? So K cannot belong to set. So out of these, which value of K can't take? Okay. So let's solve this problem. If you can see, if you will draw a Venn diagram for this, let's say 89% are suffering from heart disease. A will be 89%. Correct? And B will be how much? 98%. And K percent is common to both. K percent is common to both. So obviously, if everything is running into percentage, so total percentage will be what? Universe will be what? 100%. Correct? Now, you can say that A union B, A union B will be always greater or equal to 98%, but less than or equal to 100%. Is it correct or not? If I am doing A union B, it will be always greater or equal to 98%, but always less than 100. Correct? And what is A union B formula? What is A union B formula? N of A plus N of B minus N of A intersection B. Correct? So let's write the values here. So this is 98. A was 89 plus B was 98 minus K less than or equal to 100. Okay. So I can subtract 98 from each of the side. I can subtract 98 from here, here, here. So this will become 0. This will become 89 minus K, and this will become 98 subtracted to 2. Now I will subtract 89. Now I will subtract 89. So this will become minus 89. This will become minus K. This will become minus 87. I will multiply by minus sign. And when we multiply it by minus sign, inequality reverses. Inequality reverses. So K value should be between 87 to 89. Okay, so let's check option. Cannot belong to set. Okay, cannot belong to set. So which option will be correct in this? Option number B. Yes, because there is no value of K in this 87 to 89. No value of K is this. Okay, let's move on to next one. Which point you couldn't get, Pavaniti? Yeah, Charit, which point you couldn't get? Please ask. Yeah, I'm waiting until then other students please write. Step 3. Okay. Step 3. N of A. N of A is what? 89%. So I have written N of A 89. N of B is what? 98. And A intersection B is given as K. So I have written these values. Okay. After that, see. Let's say if I write 5 here, K here, K plus 2, and here 7. Let's say I'm writing like this. Okay. So we have to find the value of K, let's say. Okay. So what I will do, I will subtract minus 2 from all the sides. So it will be K plus 2 minus 2, and it will be 7 minus 2. This is gone. So 3, K and 5. So K belongs to what we got? 3 to 5. Same structure we are doing here. Here 98 was written, here also 98 was written, here 100 was written. So first I subtracted 98 from all the sides. So this became 98 minus 98, 0, 98 gone from here. 100 minus 98 is 2. Okay. Now what is left here? 89. So I will subtract 89 to all three sides. 0 minus 89 is 89, minus 89. 89 gone here. 2 minus 89 is minus 87. Now understood everyone? Okay. Let's move on to next one. Okay. This type of question came twice. At the last, Naman, I will show all the slides until do the work. Okay. Now let's read this question. A survey shows 63%. A survey shows 63% of the people in the city read newspaper A. Okay, read paper A or newspaper A, whatever it is. Okay. So 63% of the people are reading newspaper A or paper A. I think so. This side will not be visible. But yeah. So 63% are reading newspaper A. So total will be what? 100%, correct? And 76 were reading paper B. 76% are reading paper B. Okay. If X percent of the people read both the paper, again same type of question. X percent are reading both the paper, then we have to find the possible value of X can be. Jitesh is writing 39, but option is 39 is not here. Okay. Options are given, Jitesh. 39, Varun is also seeing, writing, sorry. 39 is not in options. Please read the option 65, 37, 55, 29. Okay, these are the four options given here. In J, you can't do it, na? You can't write like this. E option 39. Check my answer. We can't do it. Okay. So let's do this problem. So from the previous concept only, we know that A union B will be less than equal to 100, because it can't be, A union B can't be greater than the universe thing. So A union B will be less than 100. Okay, what is A union B? N of A plus N of B minus N of A intersection B less than or equal to 100. That is 63 plus 76 minus X less than or equal to 100. That is 139. So X is greater or equal to 39. So we got X value should be greater than 39. So this option and this option got cancelled. Okay. These two options got cancelled. Okay. So now we have to find that possible value of X. So X can be greater than 39, obviously. And see, if we are taking intersection of A and B, if we are taking intersection of A and B, so A intersection B will be always less than equal to B, and N of A intersection B will be always less than or equal to A. Intersection part can't be greater than anything, any of the two sets, correct? So from this we got X is less than 63, and from this we got X is less than or equal to 76. So what is common in these two? In these two, common is X is less than or equal to 63. Common part can't be greater than 63. Okay, understood? The one who has sent a photo, inequality signs are wrong there. So here X value will be less than or equal to 63. So only one option is there, that is 55. Everybody understood this one? Okay. Let's move on to next one. We are moving to next question. Okay. So here is another good question of sets only. Please read it once. So in a class of 140 students numbered from 1 to 140. Okay. So there are 140 students in a class. Each one is given a number 1, 2, 3, 4. Okay. Roll number like type. All even number took maths. All the students having even numbers took math. Those whose number is divisible by 3, like 3, 6, 9, 12, 15, they took physics. And those whose number divisible by 5 took chemistry. Okay, like 5, 10, 15, 20, 25, 30, so on. And the number of students who did not opt for any course are, like number of students who didn't took physics, who didn't took chemistry, who didn't took maths. So obviously these will be the students whose roll number is not divided by 2, 3 and 5. Okay. So will you try this one? Try this one, try this one. Take a minute. Not prime number and 1, like divisible by 7 also will be removed. Varun got the answer. Varun is using full Google Lens now. Very good, Varun. Varun is saying that I am not sure about the answer. Just read and told the answer. We have genius kids here also. Those who are reading the question and they are saying a random number 38 in this question. Yes or no? We should have these kind of genius kids here. Okay. Jitesh is another strong candidate. He is saying 0. Okay, let's start. So, in a class of 140 students, so let's say they are giving like this. It's a three set Venn diagram. Some students are taking mathematics, some are taking physics, and some are taking chemistry. Okay, I will come to this side again. We remember the question that maths is taken by how many students? So maths is taken by all the even number student. 142 by 2, that will be equal to 70. 140 total numbers are there, so math will be taken by 70 students. Correct? Now physics. Physics like 3, 6, 9 and so on. It's moving on. So how many number of students took physics? So it's a simple question of arithmetic progression. It's a simple formula for arithmetic progression. Or I will tell you a simple logic here. If you want to calculate how many numbers are from 1 to 140 are divisible by 3, are divisible by 3, what you do? Just divide 140 by 3. Just divide 140 by 3. What is 140 by 3? 140 by 3 is how much? Tell me. 46.66. 46.66. So only take the integer part. Only take the integer part. So you will get all the numbers, total number of numbers which are divisible by 3 from 1 to 140. Okay. So these are students who took physics. Now chemistry we have to find by 5. Okay. So 140 by 5 is equal to how much? 28. Directly divisible. Correct? So we got number of students took mathematics equal to 70. Number of students who took physics was how much? Was 46. And number of students who took chemistry was equal to 28. Now come this region, maths and physics. Maths and physics. Physics and chemistry. Chemistry and chemistry and maths. So let's find maths and physics. So number of students who took maths and physics. So M intersection P. So that number should be divisible by 2 and that should be divisible by 3. A number which is divisible by 2 and divisible by 3 is obviously divisible by 6. Okay? So it will be obviously divisible by 6. So 140 upon 6. What is 140 upon 6? What is 140 upon 6? Tell me. 23 point something. 23 point something, but we don't have to take the decimal part, only integer part. So 23. Number of students studying physics and chemistry. Physics and chemistry. So physics was divisible by 3, chemistry was divisible by 5. So physics and chemistry should be divisible by 15. Should be divisible by 15. So 140 by 15. That is equal to 9 point something. So we will take 9. Next term. Next term. Number of students studying chemistry and maths. Chemistry is 5, maths was 2. Chemistry is 5, maths was 2. So it will be 10. So 140 by 10, that is equal to 14. Now comes physics, chemistry, maths. So 140 upon 2 into 3 into 5, that is 30. That is 30. This will be 4 point something. So answer will be 4. So for the formula of A union B union C, we got all the values here. We got all the values 23, 9 and 14. I will just write all the values here. So let's the formula of physics intersection chemistry intersection maths will be equal to physics, sorry, number of element maths, physics, chemistry equal to maths plus physics plus chemistry minus maths intersection physics, maths intersection chemistry, chemistry intersection physics plus common of all these things. Okay, so we will just put the values here. So it will be 70 plus 46 plus 28. 70 plus 46 plus 28 minus how much we got here? 23, 9 and 14. 23, 9 and 14 plus all three. After solving, how much we are getting in this? Okay. After solving, how much we are getting this? Yeah, here it's union. Maths, union, physics, union, chemistry. After solving, how much we are getting? So it will be, I think so. Anybody solved this? 88, 122. In this also everybody is saying different answer. Very good. So let's solve this thing. 46 plus 28, 66, 74, 144, 148. Addition sum is 148. Now subtract 23, 23 is 46. So we will get how much? 102. We will get 102. Okay. So A, physics, chemistry, maths. So all combined we got 102 and total was how much? 140. So we have to find the outer region. Outer region will be what? 140 minus 102, which is equal to 30. So our final answer will be 38. Everybody understood? This is a very fantastic type of question because in this divisibility logic is being used here with set theory. Okay, please take a screenshot of this. Yeah, it was a very good question. Oh, can we move on to next one? Say once again, Shwarya, once again. Okay. Take the screenshot of this page also. Now let's move on to log question, logarithm question. Now we are moving to some advanced level of questions which came in advanced exam. Okay. So let's try this question. Yeah, hostel campus started, na? That's why. Varun is not using Google Lens now. Okay. Very good, Varun. Good habits. Pooja Bichayla is asking, yesterday class was not there because of what reasons? Very good, Roja. Let's move. Let's solve this question. So A value is given. A value is given as 3 root 2. Okay. So let's solve this thing. Log 18 to the power 5 by 4, 18 base A. So everybody knows this thing, that this power will go to the front. So 15 by 4 log 18 base A. This will look like this only. 15 by 4 log 18 base A. Okay. Now A value is given here. So I will substitute the A value here. So it will be 15 by 4 log 18. And base A is what? 3 root 2. 3 root, correct? Now, if you will just apply a little thing here, I have already told you what power of 3 root 2 is 18. What power of 3 root 2 is 18? If you just square it, you will get 18. 18 can be written as 3 root 2 whole square. So this will be equal to 15 by 4 into 2, that is 15 by. So after solving this part, we got 15 by, correct? Everybody understood this thing? Oh, it's 5, not 15. Sorry, it's 5 here. Everywhere it's 5 only. I have written 15. Sorry, it was given 5 here. Okay, thank you. It's only 5 by 4, not 15 by 4. Okay, everybody got this? Okay, now let's solve this one. Now let's solve this one. So log, what is B value given? 1 upon 5 to the power 1 by 6 and root 6. And this value is given as 1080 to the power half. 1080 to the power half. Okay. So what should we do? What should we do here? We have to see what power of this thing is equal to 1080 to the power half. So 1 by 6 can become half when I multiply it by 3. So let us assume this thing. Let's check. Log 5 to the power 1 by 6 root 6 whole to the power 3. Let us take whole to the power 3 only. Okay. And this is 1 upon 5 to the power 1 by 6 root 6. When you will solve this thing, you will get under root of 1080. Why? Because this will become 5 to the power 1 by 6 whole to the power 3. I will write it properly here. Just see here. 5 to the power 1 by 6 root 6 whole to the power 3. Root 6 cube is root 6 into root 6 into root 6. Root 6 will become 6. Correct? 6 into root 5 into root 6 is root 30. So 6 into root 30. 6 will when go inside the root, it will become 36. That is 1080. Everybody getting this thing? Any doubt in this? Okay. So it's the reciprocal of that thing. So this answer will come out to be minus 3. So we got two equation and two variable. So for solving the first one, we got 3x plus 2y equal to 5 by 2. For solving the second equation, we got minus 3. So what I will do? I will multiply it by 2 and keep this as same. 3x plus 2y equal to 5 by 2. 4x minus 2y is equal to minus 6. Add this thing. 7x is equal to minus 7 by 2. So x equal to minus half. So we got x as minus half. Correct? And what is the value of y? And what is the value of y? If I put x is equal to minus half, y equal to 2. If I will put x equal to minus half here, so it will become minus 1 minus y equal to minus 3. So y equal to 2. Now we have to find the value of this thing. So 4 times minus half plus 5 times 2, that is equal to that is equal to. Okay. Some students are having difficulty here. I will just simplify this thing again. Okay, just explain this again. Okay, everyone is having difficulty here only. So why this is minus 3? Any other person is having doubt? And Ranavi asked, I think so. Okay, I will just explain this thing again. No problem. See here. Uh, let's choose this. See, we are given 1080. Okay, so let's solve it properly. Let's solve it properly. So I can write this thing as 1 by 2 power will be transferred here. Correct? And this can be written as log 1080. And this can be written as 5 to the power 1 by 6, 6 to the power 1 by 2, whole to the power minus 1. When I will reciprocal it, power will become minus 1. Correct? Minus will also go to the front. So this will become minus 1 by 2 log 1080, 5 to the power 1 by 6 and 6 to the power 1 by 2. Now just tell me one thing. Now just tell me one thing. How to make 5 to the power 1 by 6? It's 5 to the power 1 by 6 and here is no 5. No 5 to the power root. So first we can't see what is the value here. So we will prime factorize 1080. We will prime factorize 1080. So let's prime factorize 1080. Okay. 36 into 3 is 108. Okay. So we got 36 into 30. So we will get here 6 cube into 5. I have prime factorized in terms of 6 and 5. Okay. So this will look like this, minus 1 by 2 log 6 cube into 5 and base is 6 to the power half, 5 to the power 1 by 6. What power should I raise through this base? I will get the numerator. What power should I raise the base? I will get the numerator. Tell me. Yes. I should raise it to the power 6. Then only 1 by 6 will get cancelled. So this answer will be 6. So we got minus 1 by 2 into 6, that is equal to minus 3. Minus 1 by 2 into 6 is equal to minus 3. So by this method also we can understand this logic. Okay. Okay. Let's move on to next one. We are having many questions right now. Okay. Let's move on to next one. Yes. Try this. Okay. Let's solve this question now. The product of all positive real values of x satisfying this equation. So what I will do, here it's x and here it's 5. Okay. And you can see here log x base 5 is given. So whenever something is given in power, we will take log to make this power to the multiplication thing. So what I will do, I will take log base 5 both sides. I will take log base 5 to the both sides. So here it will be log x base 5 16 log x base 5 to the power 3 minus 68 log x base 5. Correct? Here also it will become log 5 base 5 to the power minus 16. Now please understand the logic why we are taking base 5. Because when this power will go to the front, it will be 5 base 5 and 5 base 5 is equal to 1. Correct? So that's why we are taking base 5. Now this full thing is power. So we will bring it to the multiplication. So 16 log x base 5 whole cube minus 68 log x base 5 into log x base 5. This one. This is left here. It will be minus 16 only because log 5 base 5 will become 1. Understood everyone? Now what I will do? I will just take log x base 5 as t. I will just take log x base 5 as t. Okay. When I am taking log x base 5 as t, it will become 16 t cube minus 68 t into t is equal to minus 16. Everybody is understanding this thing? Any doubt? Okay, nice. So let's open this. It will be 16 t to the power 4 minus 68 t square plus 16 equal to 0. I think so everything is divisible by 4. Okay. So this will be 4t to the power 4 minus 17t square plus 4 equal to 0. We can apply splitting the middle term. 4t to the power 4 minus 16t square minus t square plus 4 equal to 0. Okay. We will take common in these two. I will take 4t square common. it will be t square minus 4, again minus sign common, t square minus 4. So we got t square minus 4 and 4t square minus 1 equal to 0. So we got t square equal to 4 and t square equal to 1 by 4. So t equal to, we got plus minus 2 and t we got plus minus 1 by 2. Always when we are doing square root, we will take plus minus sign. Is everybody clear up to this point? Okay, we have just solved the quadratic here. Now I will just put the values here. Now see, if I will put the values here, what I will get? So questions are written here. Um, okay, I will just solve it here. I'm having less space. So log x base 5 is equal to 2. This implies that x equal to 5 square. Log x base 5 equal to minus 2. So x is equal to 1 by 5 square. Log x base 5 equal to 1 by 2. X is equal to root 5, and similarly x is equal to 1 by root 5. When you will multiply all these things, everything will get cancelled. Everything will get cancelled and we will get answer as 1. Okay. 5 square into 1 by 5 square, obviously it will be equal to 1, and root 5 into 1 by root 5, that will be also equal to 1. Okay, so everybody is clear in this? Any doubt? Okay, so let's move on to next one. A very easy question. It's looking some kind of complex, but it's an easy one. It also came in advance in 2018. Okay, let's solve this one. So here it's given that log, we know a to the power m whole to the power m is equal to a to the power m into n. Correct? We all know this thing. And log, one more property of log was there. A to the power log b base c. We can interchange a and b. So b to the power log a base c. We can interchange a and b. Okay. Okay, nice. So let's multiply these two. So this will become log 9 base 2 into 2 upon log base 2 log 9 base 2 into, sorry, not in power, into, in base multiply 7 to the power half into 1 by log 7 base 4. Root 7 is what? 7 to the power half. Okay. Now one more property of log we know, that log a base b is equal to 1 upon log b base a. When we reciprocal it, b base and exponent part interchange. Base and exponent part interchange. Okay, so this will go up. When this will go up, it will be log 9 base 2 into 2 times. When this will go up, 2 will be here and this part will come to base. So log 9 base 2. This can be go to the power. Okay. So log 9 base 2 whole to the power log 2 times log 9 base 2. Correct? If we interchange these two, it will become only 4. Because log 9 base 2 is same here. If you remember by this property, we have derived one more property, that a to the power log x base a is equal to x. Because when these two will interchange, it will become log a base a, that is 1. So we are left with only 2 square. Similarly, in this question, when we will interchange this thing, it will be 7 to the power 1 by 2 log 4 base 7. This will go to its power 7 to the power log 4 to the power half base 7. And again these two became same, so answer will be 4 to the power half, which is equal to 2. So we have to multiply these two, so our answer will be 4 into 2, which is equal to 8. Right? So we are applying only these two properties here, and a very hard question of log is solved in an easy way. Got it, everyone? Okay, LHS part here. Let's say I am explaining the LHS part here. Let's say I am taking log 9 base 2 as x. I am taking this as x. For just naming, I am taking this as x. Okay, just see LHS I am solving again. So this question will look like x square whole to the power 1 upon log x base 2. Correct? I have taken log 9 base 2 as x. So this will multiply it here. So x to the power 2 upon log x base 2. When this will go up, x and 2 will interchange. So x to the power 2 log 2 base x. This will go to the power. So x to the power log 2 square base x. So x to the power log 4 base x. These two got same. So answer will be. Now I think so it's very clear to everyone. I have just taken log 9 base 2 as x, and it's easily understandable now. Charit, Naman, Salman Khan. Everybody understood this one? Oh, so let's move on to our next question. Yes, tomorrow class is there and tomorrow exam is also there. Both things are there. Exam syllabus is up to set theory. Logarithm will not come, obviously. Logarithm will not come. Only up to set theory, quadratic, and number system, some part, some question. Same formatting of the questions. And you will get the link in tomorrow's morning class, as it happened for the previous test also. Okay. Timing will be same, everything will be same. Morning regular classes, afternoon exam. Okay. So this is a multi correct question. Multi correct means more than one options are correct in this. So let's try this. Okay, let's solve this thing. So as you can see, there is base 3, base 4, 3, base 2. Okay, so something options are given like this. Okay. So what we will do, I will take log base 3. Let's say I take log base 3, both sides, both sides. So what this will give us? Log 3 base 3 to the power x, log 4 base 3 to the power x minus 1. The power will go to the front. X into 1 is equal to x minus 1 log 4 base 3. Correct? So what I will do, I will bring this here. So log 4 base 3 is equal to x times log 4 base 3 minus 1. So we got x as log 4 base 3 upon log 4 base 3 minus 1. Is any of the option matching? You can say this option is matching because 4 can be written as 2 square. So 2 log 2 base 3, 2 log 2 base 3 minus 1. Correct? So this option is correct. Okay. Now, if you will interchange, this option, I can write log 2 base 3 as 1 upon log 3 base 2. So when I will write this thing here, it will be 2 upon log 3 base 2 upon 2 upon log 3 base 2 minus 1. Take LCM. So this will be 2 upon 2 minus log 3 base 2, which is option number D, also. Okay. Since C and D are correct, B is wrong one. C and D is correct, B is wrong one. And last comes our for, let's check for option number A. So for option number A, what we will do, we will just take log base 4 now, because we have taken base 2 also. Now we will take base 3 also. We have to take base 4. Take log base 4. So it will be log 3 base 4 to the power x is equal to log 4 base 4 to the power x minus 1. So it will be x log 3 base 4 is equal to x minus 1. So we get x is equal to 1 upon 1 minus log 3 base 4. That is correct option. So we got option A, C, D as the correct one. Okay. So that's all for today. Tomorrow again we will do some interesting problems. Okay. So those who have went to college, it's good. Okay. Bye everyone.
Yesterday, we discussed the idea of the weight of a body and how the weighing machine may be able to represent the weight, or maybe it might not be, depending upon what the situations are. So, we'll continue from there. Today, we are going to take the situations of impulse and momentum conservation. All right. So let's proceed. Let's first begin with a physical quantity, what we call as a impulse. There is no specific symbol for impulse, but on many occasions you might see it is represented by the symbol I. But if maybe in some other book or at some other place, if some other symbol is used, let's not get surprised. There can be other symbols also for the same physical quantity, impulse. So now what is impulse? See, impulse is defined as the change in the momentum for a body. Okay, impulse is defined as change in momentum. Impulse is defined as change in momentum. Remember, there is just a small difference between the force and the impulse. The force is defined as change in momentum upon time. So, force is the rate of change of momentum. When we say rate of change, we mean the change in momentum divided by the time. Okay. Here you can see there is no mention of time. So impulse does not depend upon how much time is needed for the momentum to change. It only depends upon the magnitude of change. Suppose for any body, when you observe it for the first time, we call that as an initial value. So if I say the initial momentum of a body is Pi, I for initial, and if the final momentum for the same body is Pf, then impulse is equal to Pf minus Pi. Since we have not studied vectors so far, that's why I'm writing this Pf minus Pi in terms of their numerical values, or what we call as the magnitude. Later on, once you will be studying vectors, and then when you will come on to the impulse, you will see that we will express the momentum in vector form. When you put these arrows on the physical quantity, it represents that you are showing their vector form. So basically, impulse also is a vector, and it is defined by change in the momentum. So right now, since we are not going through the complete vector approach, we are assuming that the body will be restricted to move on one line only. As long as the body goes in one line, even without the vector approach, we can deal that. When a body is going on a straight line, now one thing you have to remember very precisely, that if suppose I say a body is going on the right side, and if you say the momentum is, let us say, P1. Now if a body is going on the left side, this time you will say the momentum is, say, minus P2. So on a straight line, if you say P1 is positive, the positive sign simply represents the positive direction. So if I have assumed that right side is the positive direction and left side is the negative direction, then if P1 is positive, then P2 will be negative. So whenever you are going to use this equation for Pf minus Pi, you have to follow this sign convention. You have to decide which direction you want to take as positive. Take it as positive, the opposite one would be negative. All right. So impulse is defined as the change in momentum. Let's take an example. Suppose if I say that a mass of 2 kg was moving at 10 meter per second, and it was moving towards a fixed wall. This is a fixed wall. So this is the situation before collision. Okay. Before collision, the body is going to the right side with a speed of 10 meter per second. And after it strikes the wall, it again starts coming back. And when it was coming back, at that time, its velocity became 2 meter per second. So let's be clear, this 10 meter per second is the speed before collision, and 2 meter per second is the speed after the collision. So now the question is, what is the impulse experienced or received by the block? What is the impulse experienced by the block? So that is our question. Okay. So how should we proceed? First, think of the formula. Impulse is change in momentum. Change in momentum means final minus initial, Pf minus Pi. So let's look at the situation. Initial velocity and the final velocity have changed the direction. So that means the initial momentum and the final momentum will also have opposite direction. So if I say that the initial momentum is mass, which is 2 kg, into initial velocity, which is 10. So I'll say the initial momentum is 20. All right. And I have taken it positive 20 with the assumption that the right side is positive. Okay. After the collision, now it is coming in the opposite direction. So I will say the momentum is given by negative of mass into velocity. So the final momentum is minus 4. I have not written the units for both of them, but let's be clear, the unit will be kilogram meter per second. Kilogram meter per second, and that's the unit of momentum, right? So now see, you have Pi, you have Pf. Now the formula is Pf minus Pi. So if you put the value of Pf, that is minus 4. If you put the value of Pi, that is plus 20. But in the formula, there is a minus sign. So we are having minus 4 minus 20. That makes it minus 24 kilogram meter per second. Okay. So the impulse received by the ball is minus 24 meter per second. And what does the negative sign show? The negative sign shows that the direction of impulse experienced was towards the negative side. What's the negative side? Left side. So the direction of the experienced impulse is actually going to be the direction along which the force was being exerted. Got it? So the direction of impulse is dependent on the direction of the force experienced by the body from the external agent. Now you can imagine that if the block was going to hit the wall in this direction, shouldn't wall have exerted a force in this direction? Otherwise, how is it possible that a body going along right side now starts coming left side? To do so, this wall had to exert a force in the left direction. And that's why the impulse is also appearing as a 90 thing. Okay. Repeat the solution. Solution is right in front here, beta. We have calculated Pi, we have calculated Pf. The direction has to be decided. If you take the right side as positive, the left side is negative. Yeah, the previous slide I can show you, no problem. Here is it. Okay. So impulse is the expression for change in momentum. Now, where will we usually require the idea of impulse? Let's proceed. See, there is a term called average force. Average force. Whenever you need the values of average force being exerted during some short event, at that time we usually require the idea of impulse. Now the question comes, what is average force and why should we talk about the average force? See, practically in some situations, yes, it is possible that a body is experiencing some constant force, but there are other situations also possible when the forces are not constant and they rather shoot up to some large value very quickly and again they come back to their zero value very quickly. For such forces, we call them as impulsive forces. I can give you an example that while the cricket is being played, when the ball is thrown and when the batsman hits the ball with the bat, now, imagine the time for which the ball and the bat are in contact. Is that a long time or is that a very short time? It's a very short time. It's a very small time interval. The contact time is even less than maybe 0.1 second, right? But now try to visualize that during that 0.1 second, when the ball was in contact with the bat, what would have happened? Uh, the ball was coming very fast and it strikes the bat. Maybe it will get a little deformed. Again, it will come back to the same original shape and it will be going back. So during this small time interval, you will see that the force increases and decreases in an extremely small interval of time. So if I show the graph of that force, if I show the graph of that force with the time, maybe the graph will look something like this. What does it show? The force increases and decreases in a very small interval of time. I intend to say that this delta t is a very small time interval. So maybe I can say I have shown you graphically how a ball experiences force when it is hit by a bat. Okay, and for such situation, we use the word impulsive forces. Now you can see the impulsive forces are not constant in magnitude. Okay, impulsive forces are not constant in magnitude. So whenever the things are variable, at that time you might need to go with some average value. Suppose you go through a class test in one subject and let us say you get 8 out of 10. Okay. So I ask you what were your marks? You say 8 out of 10. And I ask you what is the average mark? You start thinking, wait, there was just one subject. What is the idea for average? The word average itself makes sense when you have more than one data. If suppose you appeared for the 5 subjects, in some you got 8 out of 10, in some you got 10 out of 10, in some you got 2 out of 10. So now if you are having different marks, then only the average is going to give us a broader idea about it, right? The same way here, the force is increasing and decreasing, it is not constant. So we just want to have an idea that what would be the average force exerted. Okay, so to calculate the average force, we need the idea of impulse. The average force is defined as impulse upon time for which the force was in action. So I am calling it time of action of force. So when I say time of action of force, you should think about that time for which the bat and the ball, they were in contact with each other. All right. So whenever you need the average force in any situation, you should remember about this formula. I'm going to say FAV means average force. This would be given by impulse. Impulse is defined as PF minus PI. And for time interval, I'm using the symbol delta T. So if in a situation you have to define the average force, you will do like this. In the previous question which I gave you that a 2 kg block is coming and rebounding back, I did not ask you the average force. I could not have asked you because one data is missing so far. If I want to ask you that what will be the average force exerted by the wall, I will first have to tell you that how long does the block stays in contact with the wall. Until that contact time is known to us, we cannot talk about the average force. Okay. So, Puli Jitesh, if you have a doubt, you can type it here. Now, let us say that in the same question, I would have given you that the block remains in the contact with wall for a time interval of 0.05 seconds. If I would have added one more data to this situation, uh, then I could have asked you what the average force is. So from here I can say that the average force will be impulse upon delta t. We have calculated the impulse minus 24. So minus 24 divided by 0.05. So if you simplify this, that should become 2400 by 5, or I can say this is equal to minus of 480 newtons. So if the contact time was 0.05 second, an average force of 480 Newton was being exerted. Uh, Akshat formula is right here in front of us, beta. Impulse is Pf minus Pi, and the average force is impulse upon time. Today, we haven't discussed anything else except these two results. All right. Naman, by the graph, you mean this one graph? Which one? Which one? Yeah, this one. You mean this graph? Okay. See, I tried to show that during a small time interval, the force suddenly increases and decreases. And actually, we are not sure that is the force going to increase linearly or in some other manner, but that we were sure that the force will increase and then decrease. Because this is how it happens. Whenever something strikes with another surface, there is a little deformation which occurs. If you can see, nowadays we are having all these slow motion videos. So many strange things they show, which usually we can't see. Yesterday, I saw a video of the slow motion in which only few people were simply jumping from their feet. I mean, if I'm standing like this, suppose I simply jump like this. So if we jump like this, even when the face is shown in the slow motion, you can see that how the waves pass on the face. Deformation occurs. So when even the block or the ball and the bat are hitting each other, at that time there is a deformation happening, there is a restoration happening, and that takes a small amount of time. And during that time, the force is variable. The force does not fix to a fixed value, it increases, it decreases. That's what we showed here. All right. Will the answer be same if we took left as a positive and right as negative in impulse? Exactly. Exactly. Yes, there will be no change. See, usually the maths, when you make the coordinate system, we have a general practice of taking this as a plus x minus x plus y minus y. This is a general thing to do, but that doesn't mean I cannot do this thing. I can say this is x-axis and this is y-axis. That's usually our choice, right? So the question which I gave you, in that question, if there was no specification of the direction, then I am free to choose my direction. Okay, see, both the things can happen. There is a possibility that the question itself says that this is plus side, this is minus side. So if the directions are specified in the question, then you don't have the freedom to change it. Then you have to follow according to them. But if question does not specify the direction, then you have the liberty. You can choose, but then you should know that plus minus are only representing left side and right side. So you should just remember the case which I took here, yes, I got the impulse as negative. Why? Because I told you that I have taken right side as positive and the left side as negative. So when the impulse was negative, when the force was negative, this represents that the direction of the force is towards the left. Okay. Ruthik, I am from Chola campus in Madhapur. All right. So I hope it is clear that how to take between plus or minus. Okay. So that's average force, and that's what the direction thing I told you. Yeah. Uh, Now let's take few cases of momentum conservation. Momentum conservation. So remember, we have done this discussion of momentum conservation earlier. Let me just take a brief recap. For a system, if the external force is zero, if external force is zero, then the momentum of the system, then the momentum of the system remains constant or conserved. So everybody, let's be clear. Saying constant or saying conserved is one and the same thing. Okay, so what is the condition for momentum to be conserved? There should be no external force acting on the system. All right. Now let's try to understand this statement through some numerical applications. But before again I begin, I am again repeating that when you will be writing the momentum, if you choose this direction as positive, you have to choose the opposite direction as negative or vice versa. Okay? So just be very careful about the sign, otherwise mistakes might keep on happening. Now let's try to understand this statement. If external force is zero, then momentum remains constant. Now, even before I begin, just I would like to add one more statement. Sometimes we apply this statement on one body, and sometimes we apply this statement on a system having multiple bodies. Okay, so this idea may be applied on one single body or a set of bodies. So now let us see what I mean by all these statements, whatever I have said so far. Let us say that this is one block of 5 kg. This is going with a speed of 10 meter per second along the right side. Then there is another block of 3 kg that is moving at 30 meter per second towards the left side. So now this is the situation before their collision. They are about to collide, but this is the situation before the collision, and we are assuming that this whole setup is in some outer space. There is no gravity, there is no surface, there is no atmosphere, there is no action, no other force present. So basically, I can assume that these are isolated bodies. So that would not work for pulleys. What would not work for pulleys, Himanshu? What would not work for pulleys? So this is the case before the collision. Now, as a part of the question, I say after collision they stick to each other. After collision, the two blocks stick to each other. So find their common velocity. Okay, so that's our question. Momentum constant. See, beta, the momentum conservation will be valid only when there is no external force acting. If pulleys are there, strings are there, spring is there, they all are capable to change the momentum. So it's not only that only in the pulley systems the momentums are not conserved. even if I take the pulley into such a situation where the pulley is not capable to exert the force, still the momentum can be conserved. Okay, so the idea is not specific to pulley or non-pulley. The idea is specific to the presence or absence of external force. So let's be just focusing on this general statement. No external force has to be there, whether it's pulley or friction or whatever name we can have. Everyone has to be absent. And that's why, see, I said that we are in the outer space so that there is no confusion about the friction or anything. Now, the question is, what is their common velocity? So before we solve the question, let's first look at the situation. We are having two blocks, they are moving in the opposite direction, right? So if the directions are opposite, I will have to take care of the plus minus sign if I write the momentum. For the 5 kg, I will say initial momentum is 5 into 10, that is 50. And for this 3 kg, the initial momentum is minus of 3 into 13, that is minus 90, right? So I chose right side to be positive, I chose left side to be negative. Fine. So I have written their initial momentum. Now the question comes that if I am thinking about the 5 kg block, will the momentum be conserved? All right. So think about it. 5 kg is moving, and at some moment of time, it will collide with the 3 kg. Okay. Portion of the test. Okay, guys, portion of the test will be uh, whatever we have done till today, you can assume. Whatever things we have discussed in the class till today, let us say only that is the syllabus for it. Today and the previous classes, whatever discussions we have taken about the laws of motion, the and dimensions, everything. So whatever we have done till today, from tomorrow, I mean, I think your test is tomorrow only, right? Yeah. So even not today, yeah. Even today's thing won't be a part of that. Before today, whatever we have done, so only that one will be coming in the exam. Understanding thing will be required. In the laws of motion, whatever we have discussed so far, yes, the theory, correct. Newton's laws of motion, the theory, when is exam? Tomorrow will be the exam, Janvi. Timing, I'm not sure about, but you will be informed about that. You will be informed about that, okay? Syllabus is still whatever we did till yesterday. So don't worry that those types of numericals which we could not discuss here are going to be there. No, none of it. Even these, what I'm doing right now today, even I'm not going to put them in the test because, of course, you won't be getting the time to rethink about them. You won't be getting the time to discuss them back. So even this one, this also won't be a part of that. Whatever is being done till so far, that's it. Fine. Yeah, come back. Now, let's talk about the 5 kg. Fine. Uh, is the momentum of 5 kg conserved? So let's think about what happens to the 5 kg. 5 kg is moving. When it is moving in the empty space, there is nobody exerting any force on it. So as long as the 5 kg is moving before the collision, the momentum of 5 kg does not change. So at least till that time, the momentum is conserved for 5 kg. But the moment the collision occurs, 5 kg experiences an external force. The 3 kg is going to hit the 5 kg. So, yes, when collision happens, I will say the momentum of 5 kg and the 3 kg changes. Why? Because both of them experience a force from each other. So, one conclusion I can write is that during collision, momentum of both blocks will change. Okay. During collision, the momentum of both blocks will change. Why both of them should change? Because both of them are experiencing an external force. Force by 3 kg on 5 kg is external for 5. Force by 5 kg on 3 kg is external for 3. So since both of them are experiencing an external force, both of them experience a change in the momentum. So if my question is that before the collision and after the collision, do the momentum for 5 kg remains conserved? The answer is no. The momentum of 5 kg does not remain conserved because it experiences a force from 3 kg. Do the momentum of 3 kg remains conserved? No, it experiences a force from 5 kg. So if you look at both the blocks separately, when I was talking about 5 kg alone, I meant 5 kg is my system. When I speak about the 3 kg block separately, I say 3 kg is my system. So when I deal both of them separately as a system, then the momentum of each block is changing. Okay. So this is our one statement or one understanding so far that, sorry, uh, the momentum of each block changes during the collision. Okay. Yes. Before the collision, they were going with a constant momentum. Uh, the moment they collided, now the momentum changes, and now again they are going maybe away or whatever they are doing. No, I said they stick to each other. So now, when they are moving together as one body, again you can say now again the momentum has become constant. So for the two blocks, the momentum changes only at one instant or a very small time interval when they collide. Other than that collision event, the momentum of 3 kg and 5 kg is also constant. But usually, when we do the numericals, we try to think about what happens before collision and after collision. Okay, so yes, before and after, their respective momenta are changing. Now let's go a little step different. What happens if I start treating both the blocks together as my system? Now, if I treat the system as the sum of these two blocks, if I define these two blocks as my system, now let us try to think that for the system of these two blocks, is the momentum conserved? The first thing is that you should not think this way. Since 3 kg experienced the change in momentum, 5 kg experienced the change in momentum. Therefore, if the system contains 3 and 5, it should also experience change in momentum. This statement, what I said just now, is absurd, is wrong. This is one type of likely possibility which can come up in the mind. So just I have spoken that let's not do this mistake. The momentum of 5 kg was not conserved, 3 kg was not conserved. But if you take the 5 kg and the 3 kg as a system, there is a possibility that the momentum may be conserved. Now, how to check? When I drew the outline, you can see I have drawn an outline and the 3 kg and 5 kg are within that. So when they are colliding or when they are moving, now tell me, is there any force which is coming from outside? When I say outside, means somebody from lower side, somebody from right side, upper side, left side. No. I told you they are in the outer space. No gravity, no surface, no friction. So now if you deal both the blocks as one system, now I will say that there is no external force. When both the blocks are considered like one system, then that force which was acting between 3 kg and 5 kg, that becomes an internal force. Understood? Since 3 and 5 kg are part of the system, the force which is exerted by 3 on 5 and 5 on 3, both of them become internal force, and internal forces are not capable to change the momentum of the system. If the momentum of a system has to be changed, the force has to come from some external source. Okay, since there was nobody externally, that's why I can say that as a system 5 kg and a 3 kg, their momentum must be conserved. So during collision, momentum of both blocks will change, and during collision, momentum of uh, both blocks taken as a system that remains constant. Okay, so this is the main thing what I am trying to uh, get across, that individually the momentum is not conserved, but as together if you take the mass system, I can say the momentum is conserved. I hope we people are clear with that. So now how to proceed? I'll just need one more page. 5 is going with 10, 3 is going with 30. 5 is going with 10, 3 is coming with 30. So I say this is my system. If this is my system, then I see there is F external 0, no external force. If no external force, then momentum of the system should be constant or conserved, whatever we say, I'm calling it a constant. So when I say constant, what does it mean? It means that momentum before the collision, should be equal to momentum after collision. All right. So, what is the initial momentum of the system? See, when I write P before the collision, see, for the 5 kg, the momentum is plus 50, and for 3 kg, the momentum is minus 90. So, when I write the P before collision, I have to write the momentum of both 5 kg and 3 kg. So, I have to write this momentum before collision, and I have to write P for 5 kg plus P for 3 kg after the collision. I can equate them. I could equate them only because we had a trust in the momentum conservation. And why we had a trust? Because there was no external force present. Okay. So now see, before the collision, the momentum was 50 and minus 90. So this is our P initial before collision. Now what happens after the collision? I say I don't know. I say I don't know. I don't know, but I can write an expression. And the question said that after the collision, the two bodies are stuck to each other. I think I gave that condition. Yeah. After collisions, the two bodies stick to each other. So if they stick to each other, can I say that both of them are supposed to go at the common speed? If two bodies are stuck, is it still possible that they are going with different speeds or different velocities? No. If they go with a different velocity, how can they stay stuck? So if they are stuck, of course they have to go with a common speed. So now if they have fused, if they have stick to each other, can I say it becomes a body of 8 kg, 5 plus 3? So after the collision, if I have to write the final momentum, can I simply say 8 into V? 8 is the mass which comes from 5 plus 3, and V is the final speed, or let us say the final velocity with which this 8 kg block will be moving. Since I didn't know that, so I used an unknown 8V. All right. Now, using this idea, P before equal to P after. What is P before? This thing. How much this would be? 50 minus 90, that will be minus 40. And PF after the collision, the momentum is 8V. And since these two should be equal, I can say V will be minus 40 by 8, that is minus 5 meter per second. So when they stick to each other, the velocity is found to be minus. Now you can see the answer came itself with a sign. Now this sign is only telling you the direction. I hope you remember we took right side as positive and the left side as negative. So of course this could also have been a part of the question in the mind that, okay, they were coming in the opposite direction, but when they collide, will the combined mass go this way or will it go this way? Right? Even that was one of unknown for us. We didn't know that after the collision, who is going in which direction. So we got the answer with the negative sign. This negative sign tells you the direction that the combined mass is going towards left. Got it? So this is how we think about the momentum conservation, and this is how we apply it. Uh, I hope it makes some sense for you now. Now I'm giving one question, and this time I'll be waiting for 2 minutes. I'll wait for you to do it yourself, and then I'll cross check that. Before collision, 5 kg going at 5 meter per second and 2 kg moving at 5 meter per second. This is the situation before the collision. Okay, this is the situation before the collision, and now after the collision, now I say that this 2 kg, this 2 kg started going in the backward direction with 3 meter per second. This is the situation after the collision. The question is, what would have happened to this 5 kg? I want the velocity of this 5 kg block after the collision. Okay. Let us assume the floors are frictionless, the motion is horizontal, everything is happening in a straight line. So yes, there is no external force coming from anywhere. Only these two blocks are hitting each other. I'm again repeating, this shows the left of the dotted line is the data before the collision. Two bodies coming towards each other, they hit. After hitting, the 2 kg starts going in the backward direction at the speed of 3. Question is, with what speed will be 5 kg moving, and would that be left side or right side? Now, that's your question. Oh, great. I already have some answers. Anyways, everybody try this. I'm just waiting for a minute or two. Gayatri, I think your answer is right. Good. Naman, you can do a cross check again. Sadek, you can also do a cross check. Salman, perfect. Good. Nilesh, check once again. Janvi, check once again. See, I hope now that part is understood that separately the momentum of 5 kg and 2 kg are changing, but as a whole for the system, the momentum remains constant before and after collision. So before collision, the momentum of this 5 kg will be 5 into 5 with a positive sign. Right side is positive. Left side will be 2 into 5. So minus of 2 into 5. So that makes it 25 minus 10. So the initial momentum is plus 15. All right. So I'm sure the final momentum should also be plus 15 because momentum stays conserved in absence of external force. But the data what I have given, 5 kg's velocity is unknown. So I say the momentum of 5 kg is a 5v. V was unknown, so I put the unknown value V for it, and I'm not putting plus or minus. I don't need to think it at this point. Okay, should the 5 kg be going to the right or left? The V will automatically come with the sign. So 5V, I don't know the direction, but for this 2 kg, the direction is right side. I can say the momentum is 3 into 2. That makes it 6. So this is the final momentum, this is the initial momentum, and these two should be equal. So if I equate them, I get 15 equals 5V plus 6. So this 5V will be equal to 9. So V will be 9 by 5 meter per second. Now you see this time the answer is coming as positive. If the answer is positive, that means the 5 kg block should be going in the right direction only. Understood? Now, in the same question, one more part which is rather easy to calculate, or let's not say easy or tough, whatever it is. In the same question, I'm asking you, tell me the received impulse received by uh, number one 2 kg and number two 5 kg. I'm asking you what is the individual impulse experienced by both of them. Okay. Naman, 9 by 5 is not 1.2. 9 by 5 is 1.8. Why did the plus 6 came in that step? Beta, this plus 6 is coming from the momentum of 2 kg. See, 2 is the mass, 3 is the velocity. So momentum is mass into velocity, 2 into 3. This is how. Okay. Now I'm waiting for the answers for the impulse received by the blocks. I hope you remember impulse is given by the formula final momentum minus the initial momentum. Gayatri, if your answer 8 kg is for the 2 kg block, I'll insist you check it once again. Mm. Any other answers? 16 and minus 16. Okay. Let's see. If I first talk about 2 kg, 2 kgs impulse means final momentum minus initial momentum. All right. So for the 2 kg, see, this is the case of a final momentum 3 into 2, 6. And that is a plus 6 because the 2 kg is going on the right side. So for the 2 kg, the final momentum is plus 6 and the initial momentum, look here, the initial momentum is a minus 10, which I used here also. So if I write this minus of 10, then what we get is a 6 minus minus 10. That means 16. So the impulse received by the 2 kg block is plus 16. Okay. Now let's come on to 5 kg. 5 kg was initially having the momentum of plus 25. But what is the final momentum of 5 kg? Let's have the calculation. See, the 5 kg finally moved with the velocity of 9 by 5. So, can I say the final momentum of 5 kg should be m into v, that is plus 9. So this is having a momentum of a plus 9 in the right direction. So for the 5 kg, if I write the final momentum, should that be 9? Right? And the initial momentum was the 25. So final minus initial, 9 minus 25, that comes as minus 16. And this is not a coincidence that the numerical value of 2 have come equal. The numerical values are equal, sign are opposite. This is not a coincidence. If you change the values of the masses, you change the velocities, you let the collision happen, as long as there is no external force, the impulses received by both of them should be always equal and opposite. Okay. Uh, for the 2 kg, sir, teach a fast time almost up. Okay, thank you, Nilesh. I have already finished up. Anyways, thank you so much. Uh, Yeah, I was saying that the values of these two, they must always be equal and opposite. Right now, we have done it numerically. Now, let us try to understand that how it can be understood in terms of Newton's third law also. So, see, when two bodies are interacting with each other, suppose I say this block was moving this way and this block was moving this way. Now, when they collide with each other, what happens? They exert equal and opposite force on each other. So, let me say that the force, let's call it as A, let's call it as a B. So when they collide, the force exerted by B on A will be in this direction. Let's call it a FBA. And the force exerted by A on B will be F into A into B. Right? Now, since Newton's third law says that this FBA should be equal to minus of FAB, for every action there is equal and opposite reaction. So that's how the forces should be equal and opposite. And now if you remember the formula for the average force, when I wrote, average force was the impulse upon time, right? So I can say the impulse will be equal to force into time, right? Now, since the forces are equal, and when I was explaining you the Newton's third law, we wrote this point that action, reaction act for equal interval of time. It is not like that the action goes on for 10 seconds and the reaction goes on only for 6 seconds. That doesn't happen. So, since the force is same and the time is same, that's why their impulses should also be same. Force can be written as impulse by B on A upon time, and this can be written as impulse by A on B upon time. Since time is equal, I can say in general impulse by A on B will be equal to minus of impulse by B on A. And that's why I can say that this last data which we got, this was not a coincidence. I mean, yeah, 16 number is coming because of the data what I took, but being equal, this situation will always be existing. Okay, during the collision, the impulse by the two bodies on each other is always equal and opposite. So if a ball is hit by a bat, the impulse by the ball on the bat and impulse by a bat on the ball will always be equal. All right. So Today, we have tried to understand the idea of impulse and the momentum conservation, and we have taken few simple cases here. Uh, Tomorrow, we will take few cases of one contact force, which we call as the normal force. So tomorrow, I'll be taking few situations just to make you understand that around us, when we experience different forces, which of them are most commonly affecting most of the motion. So we will take a small discussion about, say, these normal contact force, a little idea about the tension force, a little idea about the spring force, but only very general, very basic. So at least you know how to discuss with them or how to predict something about them. Correct? So, well, that's all for today. Bye bye. Have a nice day. Take care.
Good morning, everyone. So today we are going to continue the topic. What have we learned last class? That is day before yesterday. We are going to find number of atoms, number of molecules, number of electrons, volume occupied. All these concepts we are going to concentrate. And also one more thing, we are having exam tomorrow afternoon 2 to 4. Okay. Yeah, test portion. Whatever topic I taught you, that is physical parameters, and along with the topic which I am doing, questions we are going to get, and remaining 4 questions from the totally previous, along with the chemical bonding also. We are having chemical bonding, physical parameters, and yeah, test timing is 2 to 4 p.m. 2 to 4 p.m. Mr. Shall we start now? Let's start. So whatever table flowchart which I gave you last class, I am giving you again. Please check again. Mass, mole, number of molecules, number of atoms. We are finding for molecules by molecular mass into molecular mass into Avogadro number divided by Avogadro into atomicity divided by atomicity into 22.4 liters divided by 22.4 liters. This flow chart I gave you, yeah, chemical bonding only small part are having, little bit small part, not in total. Atomicity, yeah, do. Find the number of atoms present in 34 grams of ammonia, 4 grams of hydrogen, 10 grams of calcium carbonate, 8 grams of sulfur trioxide. Yes, I'll explain atomicity. The number of atoms present in a molecule is known as atomicity. When you are doing the examples, you'll get clear idea. What is that? When I'm doing, yeah, the previous sir also gave only up to chemical bonding, up to what we do for the chapter is not done, not started. Okay. Okay, only up to chemical bondings are given. I'll give some basics tomorrow morning in the class. Don't worry at all. We'll complete this. Naman Singh, don't worry at all. Whatever needed, I will teach you tomorrow. Important part, whatever is too basic, too fundamental. Yes or no, Mr. Yes or no? So let's start now. Start with the first one, 34 grams of ammonia. Check everyone. Okay, 34 grams of ammonia. Let's start with this. What is present in the flow chart? Say this. In the flow chart clearly mentioned, when mass is given, we have to go to mole. Mole is equal to mass by molecular mass. Mole is equal to mass by molecular mass. Number of molecules is equal to, from the flow chart, number of moles into Avogadro's number. Number of atoms is equal to number of molecules into atomicity. One student asked me what is meant by atomicity. Atomicity is the number of atoms in a molecule. Because this has atomicity. For example, hydrogen, diatomic. So it is 2. Similarly, fluorine, bromine, iron, nitrogen, oxygen, these are all diatomic. Ozone, triatomic. There are 3 oxygen atoms. Carbon dioxide, sulfur dioxide, triatomic. There is 1 carbon atom, 2 oxygen atoms. Sulfur trioxide, tetraatomic. Atomicity 4. CH4, pentaatomic. There are 5 atoms, 1 carbon atom, 4 hydrogen atoms. 5. Ammonia, it is tetraatomic. 4. Phosphorus, atomic elemental form, tetraatomic. Tetraatomic. If they are giving you P4, tetraatomic. Sulfur, octaatomic. 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 There are 8 sulfur atoms in S8. Okay. Okay, fine. Fine. Got it. Kirti, sorry. Yeah, got it. Got it, Kirti. Check once faster so that we can move on with the things now. Still anyone copying? Please mention in the group. If anyone copying, I will wait for you. Or else I will go with the questions. Anyone still copying? Yeah, done. Over. Very nice. Start now. First one, what is the first example I mentioned? See this, 34 grams of ammonia. First one, A bit. 34 grams of ammonia. Find mole. Mass by molecular mass. Mass 34. Molecular mass of ammonia 14 plus 3 17. It is 2. Number of molecules number of moles into Avogadro's number. 2 into Avogadro number. Number of atoms. Number of molecules into atomicity. How many atoms are there? How many molecules are there? 2 into Avogadro number into atomicity. Ammonia, what is atomicity? 1 nitrogen plus 4 hydrogens, 5. So, what is the answer? 10 into Avogadro number. So, 6.023 into 10 to the power of 24 is the answer. Okay, check once. Check once. How many of you got? Yeah, I'll explain. No problem. Again, I'll explain. Yeah. First, finding the mole. How to find the mole? Whatever value, whatever mass they are giving you, divide by its molecular mass. Its molecular mass is fixed for each molecule. For ammonia, yeah, it is 4. Correct. Atomicity is 4 here. So it will be 8 into Avogadro number. So approximately 48 into 10 to the power of 23. Correct. Yeah. Atomicity is the number of atoms present in a molecule. How many atoms are there? If you are taking ammonia, 1 hydrogen, 1 nitrogen plus 3 hydrogens, 4. 4. Finding mole. Mole is equal to mass by molecular mass. Mass given 34 grams by molecular mass is how much? 17. 2. Number of molecules, number of moles into Avogadro's number. 2 into Na. Number of atoms, number of molecules into atomicity. So 2 into Avogadro number into 4. So what will we get? 8 into Avogadro number. So answer is approximately 48 into 10 to the power of 23 or 4.8 into 10 to the power of 24 atoms. Okay, so shall I start now? Yeah, we are doing. This is the first example only. I gave examples earlier itself. See here. Second example I mentioned here clearly. 4 grams of hydrogen. Do it now. 4 grams of hydrogen. B. 4 grams of hydrogen. Mole is equal to mass by molecular mass. Given mass is 4 grams. Molecular mass of hydrogen is 2. 2 into 1. 2. 2 moles. Number of molecules. 2 into Avogadro's number. Number of atoms. 2 into Avogadro number into how many atoms are present in hydrogen? 2. So what is the atomicity? 2. In molecule, hydrogen molecule, 4 into Avogadro number. So approximately it is how much? 24 into 10 to the power of 23 is the answer. 2.4 into 10 to the power of 24 is the answer. Atoms. Okay, I will not solve it. I'll give a minute to you to solve. Don't worry. Cherry, I'll give you a question. Don't worry. I have written 5. I changed it here, Mr. Naman. See this. 8, 4 are 8 into Avogadro number. 8 6 are 48. I changed it. Earlier I have written 5, correct? Third one. Find the number of atoms in 10 grams of calcium carbonate. Cherry, complete it. Full chapter of this is very easy part. Whatever is there for the examination, whatever I gave, That very easy part we are going to discuss in the class. No problem. Very easy. Just application. Whatever I'm teaching, just you can apply as it is. No issue at all in this. It is a simple concept. Any complexity is there, we'll solve it so that there should not be any discrepancy for you. Okay. Let's see the next question now. What is given behind this? 10 grams of calcium carbonate. 10 grams of calcium carbonate. What you have to do first? Finding the number of moles. Mole. Cherry, find it now. Mass by molecular mass. I will be waiting. Same methodology. Apply it. Okay, Cherry, you got the answer? 3.011 into 10 to the power of 23. Okay. Okay. 10 moles. Naman Singh, it is not 10 moles, no? I gave 10 grams. Means how many moles? 10 divided by, what is the molecular mass of calcium carbonate? 40 plus 12 plus 48. It is 100. Divided by 100. So it will be how much? 1 by 10. 0.1. Okay, 0.1. Then number of molecules, if you are taking 0.1 into Avogadro's number. Number of atoms, 0.1 into Avogadro number into how many atoms are there? What is atomicity of calcium carbonate? 1 plus 3. It is 5 into 5. So what is the answer? 0.5 into Avogadro number. 0.5 is 1 by 2. 6.022 or 23 into 10 to the power of 23. Approximately 3.011 into 10 to the power of 23. Who got the answer? Very nice, Dhanush. Okay, Kartika, I will teach. No problem. Leave it. I will explain. Puli, Jitesh, nice. Check once again. We are not changing anything here. Whatever we learned earlier, same thing I am giving examples. One more example, then we will move on to the next one. Everyone ready? Ready? If you are ready, please mention so that I can, yeah. Yeah, very good. Right. Find the number of atoms present in, find the number of atoms present in 64 grams of methane CH4. 64 grams of methane CH4. 64 grams of methane CH4. Fourth one, number of atoms in 64 grams of methane. Solve it. Give the answer, guys. Mole is equal to mass by molecular mass. Mass given is 64. Molecular mass of methane. How much? 12 plus 4, 16. So number of moles is equal to 4. Number of molecules is equal to number of moles into Avogadro's number. 4 into Avogadro number we are going to get then. Then what is number of atoms, guys? Number of atoms is equal to number of molecules into atomicity. What is atomicity of methane? 5. So 4 into Avogadro number into 5. 20 into Avogadro number. Approximately 12.044 into 10 to the power of 24. How many of you got the answer? Very nice. Very nice. Flowchart, I will show once again. I got it. Yeah. Parthu Reddy, good. Nice. Got it. Anyone else? Dhanush, nice. Dhanush, 1240, 12.4. Yeah, correct only. Somebody asked me about the flowchart. Just check once again. There is a flowchart which I gave you on Wednesday. Already gave you this flowchart. Those who are checking, please check again, or else we will move on to the next one. Naman Singh, correct, mister? Done. Case 2, finding mass. See, whatever we are learning right now, it is totally based on the flowchart only. Till now we are moving from top to bottom. Now we are moving from bottom to top. That flowchart, same flowchart we are going to use it. No change at all. Whatever operations we are going to do based on what I mentioned on the arrows. Okay, no change at all. Now see here, if you are finding mass from atoms, how to find? If they are giving you a molecule, how to find it? Number of molecules is equal to number of atoms by atomicity. Number of moles is equal to number of molecules by Avogadro's number. Mass is equal to number of moles into molecular mass. It is totally what I mentioned in the flowchart. Sir, all dummy and easy questions, so please give hard. Yeah, no problem at all. Jitesh, I'll give good questions. Example, find the mass of sulfur dioxide if number of atoms are 6 into Avogadro number. These are the number of atoms. 6 into Avogadro number. These are the number of atoms I am mentioning. Now what you have to do? Use this same methodology which I mentioned on the board. Same thing. Now do it. Now see here. What I gave you here. First find the number of molecules. How to find number of molecules? Number of molecules is equal to number of atoms. 6 into Avogadro number divided by atomicity. Jitesh, what is atomicity of sulfur dioxide? What is atomicity of sulfur dioxide? 3, correct. Divided by 3, it is equal to 2 into Avogadro number. Next, number of moles is equal to number of molecules by Avogadro number. 2. Mass is equal to moles into whatever moles we calculated into molecular mass. 2 into what is molecular mass of sulfur dioxide? 32 plus 32, 64. So what is the answer? 128 grams. How many of you got the correct answer? Parthu Reddy, correct. Varun Reddy, nice. Next. Any other students? Charit Reddy, got it. Pranavi, Dhanush, nice, nice. Likita, Kartika Raj Mishra, Kritika Raj. Right. Okay, guys. Take one more question. I'm giving you one more question. Use the same methodology and complete it and mention the chart. Example 2. if number of atoms are 18.066 10 to the power of 23 in a CO2, find the mass, find the number of, find the mass. If the number of atoms are, find the mass. Ready guys? Apply it. Same methodology which we learned earlier. Apply it now. 44 grams. Okay. Gayatri, Himanshu, Likita. Okay guys, I'll check once. If you're ready, please inform me. I'll start now. Ready. Now say this. Number of molecules is equal to number of atoms by atomicity. That is equal to 18.066 into 10 to the power of 23 divided by 3. CO2 atomicity is 3. So it is approximately 3.011 into 10 to the power of 23. Next, number of moles is equal to number of molecules by Avogadro number. What we are going to get? 1 by 2. 0.5. Mass is equal to mole into molecular mass. Mole is 1 by 2 into molecular mass is 44. So it is how much? 22 grams. How many of you got 22 grams? Anyone of you got 22? Anyone? Yeah, it is 3.022 is number of molecules. Check once. 3.022. Yeah, 22, approximately 3.022. So approximately it is 1 by 2 only. Approximately 3.022. Molecular calculation is wrong. No. See this. Divided by 3. It will be how much? 3.022 into 10 to the power of 23. Approximately. Divided by Avogadro's number 6.022. It will be 1 by 2. 0.5. Then we can find number of mass directly. 22. Okay. Then 18 by 3. Oh yeah, really. I made a mistake here. Correct only, mister. I am wrong. 6.022 into 10 to the power of 23. Yeah, right. Really, I didn't check. Sorry, mister. You are mentioning the same thing. I am doing my own part. It is 1 only. Correct. Thank you for correcting. Yeah, it slipped. 44 grams only. Earlier, whatever you gave, it is correct only. All the students like Jatish, some other students also mentioned earlier, it is correct. Then third concept we are going to do today, that is finding volume. For the gases only we can use this. In the flow chart, if you can see, I gave you that one clearly. See this. This is the flow chart which I mentioned as day before yesterday also. This part we completed. Reverse part also we completed. Now which part we are doing? This part we are doing now. This part. Mass to moles to volume. Mass to moles to volume. Okay. Let's start guys. Case 3. Finding the volume of the gas. Finding the volume of the gas. One mole of any gas you take on the earth, any gas, whatever gas we are taking, at STP condition, it occupies 22.4 liters volume. One mole of any gas on the earth. You take noble gases, carbon dioxide, ammonia, any gas you take, it will occupy how much volume? 22.4 liters. We call this as molar volume. One mole of any gas, at STP, what is STP condition? Standard temperature. Temperature is how much? 0 degrees Celsius, 273 Kelvin. Pressure is 1 atmosphere. Occupies 22.4 liters volume. Fixed. Means 1 mole of CH4, SO2, SO3, helium, ammonia, anything you take 1 mole, it is 22.4 liters only. Now listen to my question clearly what I am mentioning on the board. Please listen everyone. If I give you half mole of ammonia, 1/4 mole of ammonia, then what is the volume occupied by that? Listen to the question clearly, what I am mentioning. If it is 1 mole, any gas will occupy 22.4 liters if it is STP. Rohil, listen clearly. If it is half mole, half 1/2 mole, yes, very good. Kritika Ras, nice. Pardu Reddy, nice. Nice, Jitesh, correct. Himanshu Goyal, nice. Half mole means 22.4/2. Not 12.2. No, 11.2. 1/4 mole means how much then? 1/4 mole means how much? Mention in the chat. Yeah, not 55.6, Mayor Fatima. 5.6. 5.6. Correct. Correct. Right. Right. You got some idea then. Let's practice. Find the volume occupied by 34 grams of ammonia at STP, 2 grams of hydrogen STP, 4 grams of helium STP, 1.28 grams of sulfur dioxide STP. Let's start slowly. Guys. First, I gave you mass. You have to find mole. Fixed. Whatever we learned earlier. Fixed. Mole is equal to mass by molecular mass. Fixed. Now, once you get the mole, you have to find the volume. Volume of the gas is equal to number of moles into 22.4 liters. You take the questions. Then I will change the page and we can start that. Ready? Now see this. First one. 34 grams of ammonia. Find mole. Mass upon molecular mass. What is molecular mass of ammonia? 17. 34 by 17. So what is the value, guys? 2 moles. We got 2 moles. Volume occupied by gas is equal to number of moles into 22.4. It is 2 into 22.4, that is 44.8 liters. Very nice, very nice. Jashwant, correct. Ananya, correct. Himanshu, you completed all the questions. Very nice. Nice. B bit or second bit. What I mentioned? In the second bit, I gave you 2 grams of hydrogen. 2 grams of hydrogen. Mole is equal to mass by molecular mass. Hydrogen molecular mass is 2. There are atomic mass is 1. 1 into 2, 2. We got 2 moles. Number of molecules. Number of molecules is equal to 2 into Avogadro number. Sorry. 2 into 22.4. What is the value you are going to get? I gave you 2 grams, no? Sorry. Again, I made a mistake here. It is 1 only. 1 into 22.4. 22.4. Third bit. 4 grams of helium. Fourth bit. 12.8 grams of sulfur dioxide. 12.8 grams of sulfur dioxide. Now, third bit. Or by molecular mass of helium 4. 1. Here I am writing number of molecules. It is volume, no? Volume is equal to volume occupied by the gas is how much? 1 into 22.4 liters. 22.4 liters only. It's correct. Already some students explained clearly. Very good. Very good. Then fourth one. Mole is equal to mass by molecular mass. 12.8 divided by sulfur dioxide molecular mass is 64.2. Volume occupied is equal to 0.2 into 22.4. 4.48 liters. 4.48 liters. Very nice, Gayatri. Himanshu Goyal, 1.288. What is 1.288 here? No, ma, check once again. Okay. Kritika Raz, right, nice. Okay. Previous phase, fine. Let's listen to the question clearly, everyone. Everyone, ready? If you are ready, listen to the question clearly. I will give you a question. Then complete it. Ready, everyone? It may be a single like answer or multiple answer because randomly I am giving question. No, I can't say which can be the proper answer. Like it can be more than one answer also. How many of the following are having same number of same volume like that we are taking? Right, guys. How many of the following? How many of the following gases are having same volume as 16 grams of oxygen? Now, what is the thing first you have to do? Find the volume occupied by 16 grams of oxygen. How much? You find it first. Mole is equal to mass by molecular mass. It is fixed for each and every one. Okay. Follow the same methodology for each and every one. It is easy for you then. Uniformity will be there for you. Okay. Now what will we get here? 16 by 32. It is 0.5. Here, volume occupied 1 by 2 into 22.4, 11.2 liters. How many of the following gases are having 11.2 liters BDE? Himanshu Goyal is mentioning BDE. Danish is giving AB. Let's see now. A 16 by molecular mass is 16, 1 mole. So volume occupied is equal to 1 into 22.4, 22.4 liters. So first A is wrong. We can't take A. A gone case. Next, take the remaining. Second one, B, 1 by 2.5. Volume occupied 1 by 2 into 22.4, 11.2 liters. B is correct. B is correct. What about C? 1.7 grams of ammonia, 0.1. 0.1 into 22.4 liters, 2.24 liters. It is not 11.2. C is wrong. What about D? D is 32 divided by molecular mass of SO2 64, 1 by 2.5. 1 by 2 into 22.4 liters, 11.2 liters. So D is correct. Next, E. E is 40 divided by 80. Molecular mass of sulfur trioxide is 80. 1 by 2.5. So 1 by 2 into 22.4, 11.2 liters. E is correct. F. 11 grams of CO2. 11 divided by 44. 1 by 4. 0.25. 1 by 4 into 22.4. 5.6 liters. F is wrong. G. Let's take G. 8 grams of helium. 8 by 4. 2. 2 into 22.4. 44.8 liters. G is also wrong. This is also mistake. So what is the answer? BDE. I think BDE one student gave me earlier. Naman Singh, not Naman Singh. One student gave me earlier. Correct, mister? Correct. Okay. So you understood this one? Ivanshu, correct. So you understood this one? If they are giving you questions like this, can you do now? Finding the volume occupied, and you can do anything. Just that basic concept is very important. How we are dealing with the question. Yeah, nice. Okay. Now one more flow chart I will give you. Yes, one more. Yeah, I will give one more question. Sri Kirti. Yeah, one question I will give you. Complete it. Okay. Find the volume occupied by 4.4 grams of N2O. Sri Kirti, start cheyinama. Let's do it now. First find mole now. Mole is equal to mass by molecular mass. What is the mass they mentioned here? 4.4 by what is molecular mass of N2O? 14 to the 28 plus 16, it is 44.1 moles. Now volume occupied is equal to 44 into 0.1, sorry, 22.4 into 0.1, 2.24 liters. 2.24 liters. Kirti, fine? Got it? Kirti? Yes. Okay, Kirti. Let's move on to the next one. Finding the number of electrons present in a ion, molecule or atom. First, we are going to take ion. In the group, please mention, guys, what are the monoatomic ions you know? Monoatomic ions. Mono means only one atom in a ion. Next one is ions. Types of ions. What are the types of ions we are having? Monoatomic ions. N-3, nitride. S-2, sulfide. O-2, oxide. Only one atom will be present in this. No, not gases, mister. We are taking ions like cations and anions. H plus ion, correct? Dhanush, correct? H plus is a cation, correct? We can take cations like H plus ion. These are monoatomic ions. Poly means more than one atom. Polyatomic ions. Ammonium. Ammonium. Carbonate. Carbonate. Sulfate. Sulfite. Okay. Phosphate. All these comes under polyatomic, means more than one atom present in a ion. No, we are not having class on Sunday. Sulfide. This is ide ion. These are ions. Monoatomic ions, polyatomic ions. Okay. Now I am giving you a particular flow chart for the ions now. No, regular classes are going to start now. Akshat Sinha. Yes, there is a class tomorrow as it is, and afternoon there will be exam from 2 to 4 p.m. There is a class. Yeah. Shall I start now? Hydroxide also you can take OH minus. N3 minus 1 azide. Today there is no test. Tomorrow evening 2 to 4. Whatever I am teaching, that only there for you for the examination. Okay. Yeah, I think same thing I said, Mr. Akshat. Time 2 to 4 p.m. 2 to 4 p.m. Now let's see here. Saturday, yeah. Tomorrow is Saturday. No? Flow chart for ions, mass, mole, number of ions, number of electrons, divided by mass of ion divided by ionic mass into ionic mass into Avogadro number divided by Avogadro number into number of electrons in ion divided by number of electrons in ion. It is more normal whatever we learned right now. Earlier same concept, there is no confusion, but these are ions, that's all. Example, find the number of electrons in the following: A, O minus 2, mass I am giving you 32 grams. Second one, S minus 2 ion, mass 16 grams. Third one, N minus 3 ion, 14 grams. N3 minus 1 ion, 4.2 grams. First, finding mole, mass by ionic mass. What is the mass of oxygen? 16. 32 by 16, it is equal to 2. First one, sulfur, atomic mass, we know that 32 here. 16 by 32 is equal to 1 by 2. Third one, nitrogen. Nitrogen atomic mass is 14. Ionic mass and atomic mass are same. It is 1. N3 minus 1. There are 3 nitrogens. So it will be 14 3s are 42. 4.2 divided by 42, it is equal to 0.1. Now we got moles. Number of ions. Number of ions is equal to number of moles into Avogadro number. Directly you are finding now into Avogadro number. Number of ions is equal to number of moles into Avogadro number. First one, 2 into Avogadro number. Second one, 1 by 2 into Avogadro number. Third one, Avogadro number. Fourth one, 0.1 into Avogadro number. This is the last one, tricky part. Nothing is there in this. Number of electrons in the ion. How can you find? Now take first O minus 2 ion. What is atomic number of oxygen? 8. Minus 2 means plus 2 we have to add. Means how much it will be? It will be 10. O minus 2 means atomic number of oxygen is 8. 8 plus 2, 10. 10 electrons are there. So it will be how much? 10 into 2 into Avogadro number. Remaining, I am asking here, how many electrons are present in S minus 2? S minus 2, atomic number of sulfur is 16. There are 16 electrons. It is minus 2 means plus 2 we have to do. How much it will be? 18. 18 into 1 by 2 into Avogadro number. Third one, N minus 3. What is? Yeah, very good, Naman Singh. Correct. Atomic number of nitrogen is 7. Minus 3 means plus 3. So 7 plus 3, 10. 10 into Avogadro number. Next, N3 minus 1. N3 minus 1. N3. Atomic number of nitrogen is 7. 7 threes are 21. Minus 1 means what? Plus 1. So how much it will be? 22 electrons are there. 22 into 0.1 into Avogadro number. So 2.2 into Avogadro number. It is 9 into Avogadro number. It is 20 into Avogadro number. It is very simple. Only thing is we have to do more examples. That's all. Portion for the test. Akshara ji, 11 questions from the current topics like what we are doing, physical parameters, mole concept. 3 questions from the chemical bonding like that, like simple questions only, covalent bond and ionic bond, covalent compounds and ionic compounds. Along with it, 4 questions from the first topics like laws of chemical combination, everything you learn, no atomic structure, all that. 3 questions. 4 questions. Total 15 questions. They are very easy. You can do it. Don't worry about it. Okay. Not 4 questions. Yeah. Total 11 questions from these chapters like mole concept, physical parameters, and chemical bonding. Chemical bonding 3 questions are around. Remaining 7, 8 questions from the physical parameters and mole. Yeah. I don't know when to end which subject, no idea, but they inform me from 2 to 2 to 4 p.m. will be the examination duration here. Yes, tomorrow. Not only chemistry, everyone, each and every subject. 2 to 4 p.m. Okay, one more question I will mention. Let's do guys. One more question. One more question. Let's start, guys. Find the number of electrons in find the number of electrons in 1.8 grams of ammonium ion. 1.8 grams of ammonium ion. It is a cation, not anion. It is a cation. Okay. Now see here, mole is equal to mass by mass of ion or ionic mass. Okay. 1.8 by nitrogen is how much? 14 plus 4, it is 18. So how many moles? 0.1 moles. Number of ions is equal to 0.1 into Avogadro number. Number of electrons is equal to number of ions into number of electrons present in ammonium. Okay. So that is 0.1 into Avogadro number into how many electrons are present in ammonium cation? See this atomic number of nitrogen is 7. Hydrogen is 1. So 1 plus 7 plus 4 and it is plus 1 means minus 1 you have to do. It is a cation. So total how much you'll get? 0.1 into Avogadro number into 10. So what is the answer? Avogadro number of electrons. You practice and come. Very good, Dhanush. Very good. Very nice. Okay. So practice and come, guys. So tomorrow one part I will do, and I'll give brief idea about the chemical bonding in the class, so that you can do it easily. That's all from my side. Okay. So you can check the questions present in the textbook which they gave you. You check the questions and you can practice and come, guys. Right. Yes, PDF will be sent. Yeah, it is the last class for you tomorrow. Anything else? You check the examples which I gave you, then it will be very easy for you for the practicing purpose. That's all for today, guys. All the best. Thank you.
So, hello, dear students. Very good morning to everyone. I hope you can hear me, right? And also, I'm visible to you all. And you will be surprising that who am I, right? So, all these days, Kavya ma'am took the classes successfully for you since ma'am is not keeping well today. So, at the end of these classes, that you know already that tomorrow is the last session of this online class, isn't it? And today I'm here to continue with the rest of the things, right? As you already know that tomorrow you will be having the test, wherein just I would like to tell you what is the weightage of the questions, okay, from which chapter you have to prepare. 11 questions are there from Cell the Unit of Life. So there are 11 questions that will be asked from the chapter Cell the Unit of Life, and the 4 questions will be asked from the Human Circulatory System. So when you are preparing, please prepare according to the syllabus given, and also weightage also I have given you the 11 questions that you have to prepare for the unit of life, as well as the 4 that you have to prepare from the human circulatory, right? Okay, so I hope human circulatory, this is what ma'am has asked me to inform you, right? I hope I am clear, right? So as already the tissues wala chapter ma'am has started, and previously she has already completed the epithelial tissue, right? So we will be quickly discussing or revising the remaining tissues, right? And also tomorrow, right, we will be revising the entire chapter of Cell the Unit of Life, so that it will be easy for us, right, even for attending your upcoming test also, right? Okay. Yes, Meher Fatima. Yes, Nana. Okay. So this is what I have been informed, right? The tissues ka chapter is started, or the first one is completed, the epithelial tissue, right? So I will be just taking up the overall of the, what is that, the brief of the remaining tissues that we are left out with. Okay, so what is the next issue that we have to discuss? Can anybody tell me what is the next issue that we have to discuss, right? My dear, it is in the afternoon, I guess. Just let me find out and I'll let you inform before the class winds up. Right? Yes, Nana, Aishwarya, I'll just inform you before the class winds up. I'll just let you know about that. Okay, right. So, since you already know about the tissues and everything, है ना? So quickly, let us have a conversational, okay, right, class of this, right? So, tissue, epithelial tissue. What is the main function of the epithelial tissue? What is the main function of the epithelial tissue? What exactly the epithelial tissue does? Right? Kya hai role? What is the role of the epithelial tissue? You know, the main function of the epithelial tissue is, what is it? Right? One of the main function of the epithelial tissue is protection, isn't it? Right. Okay. Right. Types of the epithelial tissues, all that is done. Let me start up with the next one. That is the skeletal tissue. Right. Specialized connective tissue we have to discuss. Yes, Nana. Thank you. Right. Mm, okay. Ayansh. Okay. Whatever it is, Ayansh. Okay, Nana. So let us talk about the connective tissue. Right. So let's discuss about the connective tissue, muscular tissue, as well as what do you have? The nervous tissue. Right. So let us talk about the next one. What is it? Let us talk about the next category or the next type of the tissue, that is the connective tissue, right? The connective tissue. So what do you mean by this connective tissue? As the name itself says, that it connects or it gives a framework to the entire body, isn't it? As the name itself says, connective. Matlab, it is connecting the entire body, right? So when we talk about the connective tissue, Ayansh, can you give an example of this? Yes, Ayansh, can you give an example of this? When we talk about a connective tissue, right? Yes, very good. Tendons, right? And ligament, very good. Yes. Can we talk about the bone? Is a bone is an example of this? Cartilage. Yes, very good. Blood is a specialized connective tissue, fluid connective tissue. Let's talk about that quickly. So when we talk about this, we talk about the bone, isn't it? We talk about the cartilage, right? Okay. We talk about the blood and the lymph, which is a fluid connective tissue, specialized. We say it is a specialized connective tissue, isn't it? It's a fluid, right? So let us quickly discuss about the bone. Yes, Nana, blood, lymph, all this come under here, right? Okay, so these are the connective tissue. Let us quickly talk about this. What are the bone cells called as? What are the bone cells called as? They are called as osteo. They're called as osteo. Yes, osteo. I have already given you the name. It's just a quick revision type. Okay, because since already you have learned about this right in a regular CBC class also. So I'm just going through superficially the topics. Okay, so what are the bone cells called as, Nana? We call them as a osteoblast, isn't it? Right? So bone, we know it is a hard, right? It's hard structure, right? It gives a framework to our body, isn't it? Right? And this is basically made up of, it is hard, it is tough, due to what? It is due to the presence of calcium carbonate, isn't it? It has a calcium carbonate, 60 to 70% of this carbonate, 60 to 70%. The bone matrix is made up of calcium carbonate. Not only this, it has a calcium phosphate, isn't it? It has a calcium phosphate. So the chemical composition is important. You may get a question, what is the chemical composition, isn't it? What bone exactly, the matrix of the bone exactly made up of, right? That's okay, my dear. Hey, Ansh, that's okay, right? Okay, come back to this. Then, calcium carbonate, calcium phosphate, and the bone contains some protein, isn't it? What is the protein that the bone contains? What is the protein that the bone contains? Right? The protein that the bone contains is ossin, isn't it? Right? It's the protein that the bone contains. So it is a hard structure. When we talk about the cartilage, right? Yes, Nana, Pranavi, correct. Okay. When we talk about the cartilage, right? So cartilage, it is not that hard, right? It is flexible in nature, right? So can you give an example of a cartilage that is present in your body, right? The cartilage that is present in our body, yes, it is present in a throat, right? Larynx, the pinna that we have, isn't it? Okay, yes. Okay, so these are the nose, right? These are certain examples. And we know the cartilage is made up of a protein which is called as, yes, chondroblast are the cells, absolutely correct. And the protein that it is made up of is chondrin protein, isn't it? Right? Chondrin. The cells are called as chondroblast. Ions, right? See, everybody have their own way of, what do you say, Nana? Accent. Maybe the way I spell right, okay, right? Maybe I'm stressing it out. So that is a different point, okay? So come back to this concept. Now let's talk about the blood. Blood is called as a specialized, right? So why do we call this blood as a specialized connective tissue? What is the reason that we call this as a specialized connective tissue? Unlike the bone and the cartilage, हम इस blood को क्यों कहते हैं as a specialized connective tissue? What is the reason? Yes. What is the reason, my dear? Yes, we have Vaishnavi, yes. That's okay, Ayansh. Okay, Nana, no issues. Right? I'll try to correct it. Chalo. Okay. Let me know. Yes, gospel. Uh, yes, Nana. Why the blood is called as a specialized connective tissue? You know why? You know why. Why? Because it is. Yes, it is. Why is called a specialized? क्यों कहते हैं यार इसको हम specialized connective tissue? Because it is circulating in the entire body. Not only it is circulating, it is actually transporting the nutrients that are required for each cells and the tissues. It also collecting the waste material from those cells and the tissues. It also transporting the gases that are required for the normal functioning of the cells and the tissues, right? Okay. I teach in the Chola branch itself, this branch, right? Kavya ma'am and myself both we teach in the Chola branch. Basically, my specialization is in a botany, right? So maybe if I give you some, no, if some mistakes happen, so you have to just little bit adjust it. You can correct me, Hannah. You can correct me. See, it's a learning phase, right? So even we as a teachers, every day we have to get updated. If you teach me also, there is nothing wrong. If you give me any new point also. Yes, Nana. Kavya ma'am teaches zoology here in a Chola branch, and I take botany here in the Chola branch, right? So nice to see you all. Though it's the last class of mine, right? So the end of the session we are, but nice to interact with all of you, right? Chalo, let's come back to this, Nana, right? So I was talking about as it circulates, transports the nutrient, transports the gases, collects the excretory material, है ना? So इसीलिए we call it as a specialized connective tissue. And the fluid part of this blood is called as, what is the fluid part of this blood called as? The fluid part of the blood, yes, it's your first class and the last class. That's okay, Nana. Right. Okay. It's the first class and probably the last class tomorrow. Tomorrow we will discuss the entire chapter of the cell, the unit of life. Quickly we will have a revision, right? Because what do you say? Even from the NEET point of view, you know, that chapter has got a very high weightage. Usually you get a 3 to 4 questions from that chapter, cell, the unit of life, right? So it's one of the important chapter. Anyway, we'll come back to this. So what is the fluid form or the fluid that is which is present in this? I don't know, dear, who teaches in the Miyapur branch. I don't know. I don't know about that, Nana. Right? Hardik, I don't know who teaches you there in the Miyapur branch. Okay. Anyway, come back to this. See, we are stuck up here only. Anna. So don't worry. You are very soon. You're going to come to the offline classes in your own respective branches, Anna, and then you'll come to know your own faculties. But trust me, every faculty of the resonance, right? They are excellent. They are very friendly, right? Whatever doubts you have, you can ask them at any time, right? So they're like no, a supportive team you have. Anyway, come back to this. I was asking about the blood is made up of blood cells also, and it is made up of the fluid. What is the fluid part of the blood called? Very good. The fluid part of the blood is called as the plasma. And what is the percentage of the plasma? Yes, blood low 55 percentage of the fluid part is present, and that is what we call it as a plasma, hai na? Right? And the remaining 45%, right? Remaining 45% is nothing but the blood cells. Blood cells constitute the 45%, and the fluid part is more, that is a 55%. Yes, very good, my dear. Right, Vaishnavi? These blood cells we also called as corpus cells, my dear. Right, formed element. Yes, Nana. Now, if I ask you again, what exactly the plasma contains? What exactly the plasma is made up of? Plasma is a fluid part, hai na? Right? What exactly that contains again? Plasma again contains around 90% of the water only, isn't it? Kada? 90% of the plasma is nothing but the water itself. 7% it contains certain proteins also, isn't it? So that is all about the plasma. Let us quickly talk about the blood cells, Nana. You know, there are three different types of the blood cells, isn't it? One is a erythrocytes, which we call it as a red blood cell, right? One is a leukocytes, which we call it as a white blood cells. One is a platelet, which we call it as a thrombocytes, isn't it? Now, which cell actually transports the oxygen? Which blood cell actually transports the oxygen? Which one transports the oxygen? Which cell? The blood cell. Very good. RBC, red blood cell. Acha, when you might have seen whenever है ना सबने अपना blood का color तो देखा है यार. We say in a movies, right? Rang, है Udku raktam Telugulo. And most of you, know, I think Telugu also, right? Right? So the blood is red in a color. Why? Which pigment is imparting the red color, Nana? Which pigment imparts the red color of this red blood cells? It is hemoglobin. Very good, right? It is nothing but a hemoglobin. And you know that hemoglobin is just like a boat, yaar. Hemoglobin is just like a boat. Imagine it's a boat. In this, on these hemoglobin, what will come and bind? Oxygen. Oxygen where the oxygen binds, it binds onto the hemoglobin, and then hemoglobin transports the yes, the oxygen. We say that it actually RBC transports the oxygen. So erythrocytes are red in a color due to the presence of what is it, right? Okay, hemoglobin, which helps in transportation of oxygen. Then comes the WBC, the white blood cells, right? The white blood cells are actually called as the army of the body. Why do we call it as an army of the body? Because it fights against the infectious. It protects our body, isn't it? Very good. It fights against the bacteria. It fights against the viruses, right? So can we just commonly call it, my dear, that it protects us from the pathogens? Ayansh, can we call it as it protects from pathogens? Yes. Hannah, you said it protects from the bacteria and viruses. But in general, yes, Nana. I'll tell you what is the reason. Gospel. Yes, thrombokinase, that we will discuss. Okay, now look at this. Now, as Ayan said, that these, what you said, WBC cells protects us from the bacteria and viruses. But in general, we can just substitute the word, right, with the pathogen. You know what are these pathogen? What is the meaning of the pathogen? Pathogens are those microbes which causes disease. Pathogens are those microbes, yes, very good, germs. But now Ayans, now you are in a class 11th, है ना? So germs का concept khatam. When you were in a lower classes, so these were called as a germs, है ना? But now we have a particular word, Nana. We call them as a microbes. We are grown up now, isn't it? So we call them as a pathogen. So pathogens are those microorganisms which actually causes the disease. So WBC cells will protect us from these pathogens. Achha, if we talk about, right, WBCs, what are the different types of these WBCs, Nana? Right? Can you tell me? Can you tell me? Have you ever gone to the hospital? If you're not gone, by God's grace, right? We wish you never face it, right? So, eppadana hospital kelte, my dear, very good. Vaishnavi is telling the answer. You can see, they'll give you the blood test, and in the report, you can see the 5 different types of the blood cells. There you can see, very good, Nana. Right, there you can see neutrophils, macrophages, monocytes, eosinophils, basophils, है ना? Right? So what do you see? We see all this percentage, neutrophils, है ना? These are all those army of our body. Then what do you have? Macrophages. Do you have? Do you have this? Right? Okay. Let me write it. Okay, neutrophils, monocytes, right? Eosinophils, right? And then you have what? Basophils, macrophages, and all these things, right? And they have got their own individual, what you say, right, role to perform in our body. Achha, what is the lifespan of the WBC cell? What is the lifespan of the WBC cell? What is the lifespan of the RBC cell? Lifespan of the WBC cell and lifespan of the RBC cells. 6 to 7, 6 to 7 days, 6 to 7 days, right? And RBC, right? When we talk about the RBC lifespan, right, it is about 120 days, 120 days. And where do they die after 120 days? Where do they go and destroy themselves after 120 days? Liver. Okay, I answered liver, right? The correct answer is spleen. Spleen, Nana, right? Spleen is called as the graveyard of the RBC. Graveyard of the RBCs, because after the 120 days, right, through the circulatory system, that is through the blood, they just go to the spleen. Spleen is a small organ, right? And there they actually destroy. I mean, they get destroyed. That is why we call it as a graveyard of the RBC cells. If we talk about the last cell, that is what is the last one? The platelets. When we talk about the platelets, Nana, acha, tell me, what is the speciality of the platelets? What is the speciality of the platelets? Platelets are also called as thrombocytes. What is the speciality of the platelets? Yes, clotting factor. Very good. Clotting factor. Done. Give me a moment, just drink some water. Okay, clotting of the blood, done, thank you. Right, platelets are called as thrombocytes, right? And there was a question that was asked by someone that do we call these platelets also as thrombokinase? Can we call this as thrombokinase? The answer is, can you answer? Yes, Vaishnavi? Nana, there was a question. Can we call these platelets as a thrombokinase? Is that correct? No. Thrombocytes and antam. We call it as a thrombocyte, but not a thrombokinase. Thrombokinase is released by these platelets during the clotting of the factor. Is this clear? My dear, gospel full name, I couldn't see, Nana. Right, you asked, can we call it as a thrombokinase? That's wrong, because the kinase is a particular enzyme that is released during the clotting factor. It's a releasing factor, and we know it helps in the clotting of the blood. Clotting of blood. What is the lifespan of these platelets? What is the lifespan of these platelets? Okay, done, Nana. Right? Okay, very good. 8 to 10 weeks or days? Is it weeks or days? Is it weeks or days? Yes, it is a days. It is 8 to 10 days. Or weeks. Vaishnavi says weeks. Jashvita says days. Hmm? Ayansh. Where is Ayansh? Ayansh. Yes, it's days. It's not a week. Correct. It's a days. They survive for 8 to 10 days. Okay. Right. Let's talk about the next thing. Very good. Right. So shall we talk about what is the next one? Let's go to the next one. Nervous system, and then we'll come to the right nervous tissue, and then we'll come to the last one, muscular tissue. Acha. You know this, yeah, nervous tissue. We have been, yes, I am. I know, Nana, you are present, but I just asked you what is the lifespan, right? Okay, acha. Let me know now. We are talking about the nervous tissue. We have been studying this from class 9th. You had a chapter, CBSE, है ना, tissue wala chapter. What is this nervous tissue, Nana? Okay, nervous tissue. First thing, right? Okay, nervous tissue. What is the main function of this nervous tissue? No, it carries the messages. It communicates. It carries the messages from the receiver or receptor cells to the brain. and also it brings, yes, very good, impulses, Jashvita, right? It carries the messages from the sense organs, right? It carries the messages from the sense organs given to the brain, and brain will give you the command or the response, which again it carries back to the sense organ, so that accordingly we can respond, right? So nervous tissue is a tissue which is basically involves in carrying the messages and bringing back the information, so that the muscles react accordingly, isn't it? Yes, they react according to the stimulus. Yes, peripheral nervous system, right? Right, obviously they are the types. Okay, so mainly I'm talking about the general one. So carrying the messages, है ना, transport the messages, carrying the information, right, reacting accordingly, right? Right, and already you have told me sensory motor nerve, very good, right? And nervous tissue, basically it is made up of nothing but the nerve cell. Actually, do you know what is the size of the nerve cell? Okay, let me ask you a question, since we have already discussed the cell, the unit of life also. Acha, every cells will divide, isn't it? Every cells will divide because the cells divide for the growth, they divide for the development, they divide to repair the damaged or the worn out cells and the tissues. Can you name the two cells of our body which will never divide? The two cells of our body which will never divide. Can you name the two cells of our body which will never divide? Right? Meher, yes Nana, न्यूरॉन. दो सेल ऐसे सेल है हमारे बॉडी में जो डिवाइड नहीं करते. अगर कोई भी डैमेज हो गया, वो डैमेज परमानेंट होगा, राइट? ऐसे कौन से दो सेल है यार जो अपने बॉडी में डिवाइड नहीं करते? वेरी गुड, वन इज अ न्यूरॉन, वेरी गुड वैष्णवी. व्हाट इज द अदर वन नाना? व्हाट इज द अदर वन? कार्डियक, वेरी गुड Zareen, right? Heart cells as well as the brain cells, they never divide. That is the reason any damage that occurs to the brain cell or the, what is it, heart cell, it's a permanent damage. You cannot replace those cells. But the other cells, you take the skin cells now, है ना, you take the liver cells, you take the kidney cells, you take the n number of the cells, they divide यार mitotically, right? लेकिन हमारे बॉडी में ऐसे दो सेल है जो ब्रेन सेल है, सॉरी द ब्रेन है ना, द ब्रेन सेल है और हार्ट सेल है, that never divides. Okay, right? So we are talking about the nervous tissue, right? Neuron, what is the average size of this neuron? Nana, nerve cell, it can range up to one. I've given already the clue, one. Now you have to tell me, is it 1 mm or 1 m? Is it 1 millimeters or what do you say, 1 meter? 1 millimeter, छोटा सा. 1 meter, very good. Not micrometer, not micrometer Zareen, micrometer नहीं है बच्चे, it's very long, you know, right? It very good, it can range, right? So nerve cell, right, or neuron, है ना, and it can range, the size is about 1 meter long, such a long nervous system. I mean the nerve cell. And you know the parts of this, isn't it? सबसे आसान है ना? The parts of this, quickly you have to tell me what are the parts. I'm happy, right? You are very quick in answering. Happy to see that. Right, tell me Nana. Okay, so nerve cell, right? Acha, which is the largest cell of the body? Largest cell of the body and the longest cell of the body. If we make a chain, very good, I answered something, through all the nerves in our body, we can bind them 7 times around the earth. Yes, this is a fact, right? Very good, I answered. Thank you, Nana. Right? The science says if you remove all the nerve cells, although we cannot do that, right? If you take out all the nerve cells and then you just try to coil them, right? So you can coil the earth around 7 times. Very good. I got the Hardik said, okay, Hardik said nerve cell is the longest cell. Very good. Zareen, ovum is the, yes, largest cell. Very good, Nana. And which is the smallest cell of our body? Which is the smallest cell of our body? Yes, very good. The sperm is the smallest cell of the body. Acha, chalo. Let's come back to this quickly, है ना? And let's, nucleus, axon. Yes, very good. Okay, very good, very good. So what are these actually? These are called as dendrites. These are actually called as the dendrites. है ना? What is the role of the dendrites? What is the role of the dendrites? The role of the dendrites is to receive, or what is it? The role of the dendrites is to receive the information, isn't it? They are very closely associated with the receptor cells. These are the sensory organs. Since skin is a sensory organ, nose is a sensory organ, ear is a sensory organ, है ना? So these dendrites are closely associated with this, right? And they take the messages, they collect the information, isn't it? Right? Yes, Nana. So they receive the information through this dendrites. And what is this actually? This is called as what? The cell body, right? Acha, what the cell body is made up of? What is the cell body made up of? When we say cell body, क्या क्या आता है उस cell body में? What the cell body constitute? The cell body contains what? Nucleus, right? उसके अंदर cytoplasm, yes, Nissls granules, है ना? Everything, right? अरे यार, it is a cell. Obviously, it have all the contents of the cells like other cells, है ना? It require all the cell organelles. It require all the cell organelles. So when we say the cell body, the nucleus, the cytoplasm, all the contents that are present in this. Right. Okay. Now this long part that you see, elongated part, is what we call it as an axon. है ना? What is the role of this axon? What is the function of this axon? The function of the axon is to carry the impulse. Oh, Ayansh has given the parts. Yes. Cell body, dendrite, nucleus, myelin sheath, Nissls granule, axon, very good. Swan cells, right. It acts as an insulator. Acha, Zareen, does it act as an insulator? Bache, does it act as an insulator? Insulator? It depends on what is that? Myelin sheath. What is the role of the myelin sheath? What is the role of the myelin sheath? Right? There is a sheath, isn't it? इसका role क्या है? What is the role of the myelin sheath? What is the role of this? Protection. Yes. Right? This acts as an insulator. Right? This acts as an insulator, Nana. Right? Okay. Nodes of Ranvier का role क्या है? What is the role of nodes of Ranvier? Right? What is the role of this? Spellings. If the spelling is wrong, you can correct me. Myelin sheath, right? And then you have the last one. This is what? Axon terminals, right? Okay. And there is a synapse between the two adjacent nerve cell. What is the role of the synapse, Nana? What is the role of the synapse? What is the role of the synapse? Very important this is, isn't it? Electrical impulse. Very good. Right? Electrical impulse. It receives the information. Very good. है ना? So you know already, my dear student, as the message or the impulse is carried out, isn't it? So throughout the nerve cell, the impulse is carried out in the form of electrical impulse. But at the synapse, at the gap that is present between the two adjacent nerve cell, there the impulse is carried out in the form of chemical, isn't it? Neurotransmitters are present. Am I correct? Right? Am I correct? The impulse, when it is carried out through the nerve cell, है ना? Two types, isn't it? As the impulse is carried out through the nerve cell, it is carried out in the form of the electrical. Impulse is nothing but what is an impulse? Yes, Hardik says what is an impulse? What is an impulse, Nana? Impulse क्या है? Simple. Let me see, check it out whether my, yes, nothing, very good. It's a message. Hardik, now you see, Nana. What is it? Okay, let us take an example. Okay, let's take an example. You go to the kitchen. Now you all are at home, right? attending the online classes, है ना, right? Every time you feel hungry, you ask your mummy, mummy ye mundi kitchen lo, mummy what is there to eat, mummy what is there to eat. Suddenly you visit the, I'm just giving it's a very bachusa example, you go to the kitchen and there is a hot pan or something and your skin just touches to it, है ना, and what happens, your skin is a receptor, what is it, it's a sensory organ. The nerve cell that is closely associated to this sense organ, it first take that message, है ना, that something hot is touching it, isn't it? It receives the message. That message is what we call it an impulse. Impulse is nothing but information or the message, Nana. And this message is carried out, it is transported. The message what we call here is impulse. It is transported in the form of electrical impulse. You will study in detail about this, how this electrical impulse is called, what happens exactly, what is the movement of the ions, positive, negative, you will study in detail. As of now, you should know as the message is or impulse is carried out through this nerve, it is an electrical impulse, but as it comes to the synapse, the gap which is present between the two adjacent nerve cells, there the message or the impulse is carried out in the form of chemical. It is transported or transferred in the form of chemical through the neurotransmitters, isn't it? So impulse is nothing but message or a information, right? So what is the role of the synapse? Acha, synapse is a, what is synapse? Synapse is a gap, isn't it? Right, that is present, the junction that is present between the two adjacent nerve cell, one nerve cell, another nerve cell, isn't it? Right, and the gap that is present between the two nerve cells is what we call it as a synapse. Am I correct? Right, synapses is different, synapse is different. Synapses आप पढ़ोगे in the chapter cell cycle and cell division. So how will you define synapse? How will you define the synapse? Already I have told you. Yes, how are you going to define the synapse? Come on, yaar. Already I have told you synapse. What is synapse? What is synapse? What is synapse? Already I have told you, Nana. Right? Oh, right. Specialized junction. Synapse. Right? If you want to just look at here, right? Let's say this is one neuron. Let us say this is one neuron. You know? This is one nerve cell. These are the dendrites which will receive the information, right? And these are the terminals of this. And there is another nerve cell, right? Another nerve cell is connected like this, right? Okay. Now you see what happens here, right? These are the terminals. And again, you have the dendrites here. Again, you have the dendrites here. Now, these are two cells, Nana, two nerve cells. Now, the gap that is present here, right? The space that is present here, this space between the two adjacent cell is what we call it as synapse. The space that is present here is what we call it as the synapse. Yes, the impulse between the two nerve cells, the adjacent, the message that is carried out here is a chemical impulse. Exactly how do you define this junction that is present between the two neighboring or the two adjacent nerve cells is what we call it as the synapse. Is what we call it as a synapse. So it is a junction where the nerve communicates with another, right? Is it clear? And how is this communicating? The communication or transmission of the messages carried out in the form of electrical impulse. Yes, very good, Ayansh. It is a, yes, Nana, specialized junction. That's what I have said. It is a space, it is a gap, the specialized junction where the communication takes place, right? Okay, the axons of the other nerve cell through connection is called, yes. Okay, so this is how, that's what we call it as, na, they are like connect, they're transporting or transferring the information for which they have to be connected, and that's junction between the two cells of the nerve is what we call it as the synapse. So synapse mein kya hota hai? In the synapse, the messages are transported in the form of electrical. Okay, I have been asking you the same question again and again. What is the role of the mesal granules and what is the role of node of Ranvier? What is the role of Nizel's granules and what is the functions of node of Ranvier. Already it's 12:15. We'll finish the muscular tissue and then we'll wind up. As I've told you, tomorrow we'll revise the chapter of cell, the unit of life, Nana. Yes, what is the role of this? Yeah, no, Nizel's granule contains something like proteins. Yes, obviously. Yes, obviously. And role of Ranvier, what is it? Those are gaps that are present, uninsulated gaps that are present between the myelin sheath. Am I correct? If you just look at this, where is the node of Ranvier? This one. Am I correct? The gap that is present, है ना यहाँ पे, this is what we call it as that. So that is the node of Ranvier, which is actually the uninsulated gap, right? Nizel's granules, yes, they contain some particular proteins, right? Okay, let's talk about the next one quickly. What is it? The last one. The last one. What is this? The muscular tissue. Muscular tissue, right? So what is the role of this muscular tissue? What is the function of this muscular tissue? Right? What is the function of this? Yes, Nana. Pranavi said myelin sheath is interrupted at regular intervals. Yes. So, thank you, Pranavi. But that is what I have told you in a simple way, right? This myelin sheath is not continuously present. The gaps that are present between this myelin sheath, these small gaps is what we call it as node of Ranvier, right? Let's talk about the muscular tissue. What do you mean by muscular tissue? You know, right? As the word itself says, muscular tissue. That means this is made up of the muscles, right? It helps in the locomotion. It helps in the movement. It enables us to do the work, isn't it? Yes, Nana, they have two fibers, absolutely myelinated and non-myelinated, right? Right. So let's, yes, muscles, power, work, very good, right? This muscular tissue helps us in a movement, na? It helps us to do the, what is that? The work, right? Now, what are the three different types of the muscular tissue? What are the three different types of the muscular tissue? There are three different types of the muscular tissue, है ना? We have got striated muscular, है ना? We have got then striated, smooth, right? Skeletal, yes. Then we have one more, cardiac, yes. Okay, so let us quickly discuss about the properties of three, right? So we have skeletal, right? Then we have, what is it, next one? Smooth muscle, right? And then you have cardiac muscles. And then you have cardiac, right? So let's talk about this. Skeletal is also called as, I already gave you the name. They're also called as striated or unstriated. Striated or unstriated. Skeletal. No need to Google it up and then answer, Nana. You can answer me what you know. Very good. Right? Skeletal muscles are also called as striated muscles. Right? They're also known as striated muscles. What is the reason that they are called as the striated muscles? Striations ka matlab here is band. Dark, light. Dark, light. Right? See, when you just look at this structure, let's say these are the, right, the structure, a muscle, right? When you observe this under the microscope, you'll get a dark band and a light band. You'll get a dark band and a light band. You get a dark band and a light band. So this is alternatively present, right? So presence of these band alternatively, right? These bands are called as striations. So this muscle is also referred to as a striated muscles. When we say smooth muscles are also referred to as striated or unstriated. Smooth muscles को क्या कहते हैं? Striated or unstriated? See, one is a striated, so obviously the other will be. One is a striated, obviously the other one will be. Yes, very good. Non-striated. Why are they non-striated, my dear? Why are they striations? Why are they non-striated, Nana? Right? No bands present. Correct? No striation. Non-striated. Non-striated. है ना? Because bands are absent. Acha, which one is very closely present to the bones? Which one is very closely present to the bones? Which one is very closely associated with the bones? Is it the very good, right? Skeletal muscles, all right? So these are the bands, right? Dark and light bands, striations, dark and light bands, right? Dark and light bands, which we call it as striations, right? Closely associated, closely associated with the bones, है ना? That is why we call it as a skeletal muscle, ना? क्योंकि these are closely associated with the skeleton system. Very good. And what are the other points, Nana? When we talk about the smooth muscles are, they're not closely associated with the bones, but they are present where? Smooth muscles smooth होते हैं, right? कहाँ present है? They are present. एकड़ा? Where are they present? Acha, cardiac muscle. Okay, come back to the gospel. Gospel said cardiac muscle is present in the heart. Acha, okay, you are correct. Present in a heart, right? Present in heart. Specialized cells which are present only in a heart. Okay, right. I'm talking about this non-striated, Nana, right? Non-striated, if you see, non-striated doesn't have any striations and non-striated has a tapering end. Isn't it? Yes, very good, very good. They are actually present interiorly, right? They're not closely associated to the bones, right? They are smooth, present interiorly, and actually they are involuntary. Very good point. These are voluntary in action. These are voluntary in action. That means these are under our control. So I can lift my arm, I can put it back, I can walk, I can run, because it's because of the voluntary. I can stop, however, whenever I want. So voluntary actions shown by the skeletal or striated muscles. But these are present inside, and basically these are involuntary in action. Involuntary muscles. So why are they involuntary? Because you cannot control these activities. Very good, Nana. Blinking of eye, Fatima. Blinking of eye. Okay. Heartbeat. Heartbeat basically comes under smooth muscles or cardiac muscle. My dear Fatima, heartbeat be involuntary hai, isn't it? Even that also is involuntary, but that comes under your cardiac muscle. Here, can you give an example? Yes, Vaishnavi, right? Can you give an example for the smooth muscles? For the smooth muscle, they are involuntary. Can we take the example of this? Okay, very good. Breathing, involuntary action, respiration. Okay, then stomach is made up of the smooth muscles also, right? Your esophagus is made up of that, isn't it? Then, very good. The blood vessels, yes, flowing of blood, very good. Then, yes, then what else? What else? What else, Nana? They are fusiform, they have a tapering end, right? So blood vessels, stomach, intestine, esophagus, right? So fusiform, right? Fusiform, fusiformed, है ना? They have a tapering end, pointed end. Tapering का मतलब pointed end, present in the intestine. Very good. Yes, digestion. है ना? It's not under control, na? Gospel. It is not under our control, na? Right? So it is right involuntary action. See, you take the food, you chew it. That is okay. You can control it. But as it moves into the esophagus, goes to the intestine, the right, digestion portion, that is not under your control. You cannot control it. Chalo, carbohydrates ka breakdown karo. So these activities are not under your control. Okay, respiration, right? You see, you breathe in, breathe out, breathe in, breathe out. There is a rhythm. Our body follows it. So this is again an involuntary action, right? So all those things come under this. Let's talk about the cardiac muscles last. Cardiac muscles, again, are they voluntary or involuntary? Voluntary or involuntary? Right? They are again involuntary in actions. Right? They're again very good. They are again involuntary in actions. One more point you have to tell me about this, Nana. How is the structure? Involuntary in actions. How is the structure? Cardiac का ना एक special property है, right? It shares the property of both the, what do you say, the cells. What is that you have to tell me? Yes, stick together, okay? They are contractile tissue, right? They are contractile in nature. You have to tell me, Nana. You have to tell me. They also have a striations and they are branch. They show striations and are branched structure. And are branched structure, right? So you know striations, they also show some light striation and branching can be seen. And branching can be seen like this. Branching can be seen. Not clearly drawn as per this space I have just drawn it. Intercalated disc, communication junction, yes, they are contractile in a nature, contractile tissue. One of the cell contracts, they get the signal, the other neighboring cell also start contracting, right? So they are contractile in a nature, contractile tissue. So these are the general points that you have to remember. That's it. So I think almost we have covered, and obviously nucleus will be there present, right? These are the nucleus we know, right? So need not talk about that. Nucleus is called as the brain of the cell. Why is this called as a brain of the cell? Why is the nucleus called as the brain of the cell? Last, I'm winding up. Why do we call the nucleus as a brain of a cell? Because all the organelles, right? All the functions. Yes, very good. Right. So here we are done with this. See, I have not gone through the detail of this, right? So because ma'am just asked me to go superficially so that I can just take tomorrow's class for the revision, sell the unit of life. So just the quick points we have revised. Hope it was useful for you, right? Yes or no? Or anything else? Yeah. Thank you, everybody. Thank you. So see you tomorrow. Tomorrow also I'll come to take up with the last thing. Sir, exams, just hold a second. Exams timing ante cheppagalara. Enta? Pakkana? So yes, Nana. Yesterday's PDF, yes, I'll ask her to send it. And tomorrow's exam timings are in the afternoon, 2 to 4. Yes, somebody asked me the timings, Nana. It's a 2 to 4. So morning as usual, right? And 2 to 4 you have your test. I gave you 11, that is from cell the unit of life, and 4 from the circulatory. Done. You have a circulatory, right? Yeah. Right. Thank you, everybody. Thank you, everyone. Take care. Bye bye, Nana. Thank you so much. Bye.